Yeah, Dr. Saab, we've been talking about some good initiatives. Menak mentioned briefly yesterday evening, and I think this is the idea of such conclaves, of such e-conclaves. In fact, the conferences, what CIDM also does over the past 10 years, there are so many initiatives which are being undertaken by various agencies, government bodies, industries. Few of them are in silos. Our idea is only to break those silos. What CVR Murthy Sahab always tells me, that breaking those silos, consolidating what is happening in the ecosystem. I think that is the biggest service one can do. Doing a new initiative is always good, but consolidation of existing initiatives is also a very key aspect of making this ecosystem more reliable and more resilient. So, and that is the theme of our 2-day conclave. Also, I'm very proud to share that, with due efforts of everyone involved, the partners in form of National Disaster Management Authority, National Institute of Disaster Management, MHA, Economic Advisory Council to the Prime Minister, uh, Department of Promotion of Industries and Internal Trade, Ministry of Commerce, DPIIT, Gujarat Institute of Disaster Management, Government of Gujarat, Asian Disaster Preparedness Center, Bangkok. All these partners who are members of the CIDM group, chaired by none other than Lieutenant Dr. J.R. Bhardwaj, who's a former member of National Disaster Management Authority and the former DGFMS, Indian Army, Indian Armed Forces. I think under his leadership, we've been able to put all of this together and this would not have been possible, and I'll be very honest and blunt, uh, with the very, very invaluable inputs from and advice from Professor CVR Murthy. Thank you so much, sir. Professor Chandan Ghosh from IIT Jammu. I think we've been very, very fortunate to have mentors like you who've been advising us and uh, guiding us all this way through till here, till today. We've been able to, actually execute this e-conclave. And as I promised you previously, also, this would not be the just a one-off initiative of discussions or deliberations. We will have actionable points coming out of this, and we have already had an offline discussion yesterday evening with NDMA and with a couple of industries. We have Rituraj Mehta ji here with us, an eminent professional from the industry. SVR Subramaniam ji from EIL. Thank you so much for joining, sir. And Dr. KJ Devasia uh, from BIAL, International Airport Limited, Bangalore. I think all of these, we have Sudeep ji joining us from EIL and Papia Mandal already with us. I think we have a good set of professionals and intellectuals and technocrats with us who will be talking on the subject of earthquake, fostering earthquake resilience in industries and future developments. So it's a perfect stage. And I'm very proud to also mention that yesterday we had over 2,000 views on our e-conclave, which I think is a record of sorts. Uh, uh, I take not only on behalf of my team, and we have Akhil Gupta here, Menak Majumdar, Sanjeev, um, Kumar, and Varun Sharma, and on behalf of the entire team and on all the organizers, I think we take personal pride in this. That reaching out to 2,000 industry delegates, people from the academia, professionals, architect, students, and professionals. I think it's a personal achievement, and I think CIDM and General Bhardwaj is, as he said last evening to me, that it's a proud day for us that we could touch the 2,000 mark. That's a good outreach. I think it's a decent outreach for this platform with what we have created. So today, the second day, first day, as I said, was a successful day where we spoke about uh, critical, infrastructure to mitigate earthquakes was the technical session. Theme 2. For theme 1, the technical session 1 was on financial infrastructure, where we had partners from Swiss Re, India branch, and the Swiss Reinsurance Company. Very interesting presentations were made, from insurance products for earthquake, lessons learned from recent earthquake in last decade. I think um, as a layman, I think the simplicity with which they explained what exactly needs to be done when you're dealing with insurance and insurance related products, I think it was uh, really a delight to listen to them. We also have our principal sponsors in form of Swiss Re, and our associate sponsors in form of RMSI. And we have Sushil ji with us. A very good morning, Sushil Gupta ji. Thank you so much for joining us. Uh, so starting today, I
Very good
have
morning.
uh, so now today the technical session 3, which is earthquake resilience, case studies and importance of retrofitting. We have some very eminent speakers, and we have our chairman, Shri Rituraj Mehta, who's the corporate head, safety and BE Adani Power Limited, Adani Transmission Limited, Adani Infrastructure Management Services Limited, and Adani Road and Water Business. Almost the entire gambit of infrastructure related work of Adani. I think it's so very relevant and pertinent to have you, uh, uh, Rituraj ji, with us amongst us. I think thank you so much for joining us and being
Thank
a
you.
part of this session and agreeing to chair this session. We have uh, 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 four presentations rather, from Dr. KJ Devasia. The first one on earthquake resilience at Indian airports, challenges and way forward. He is the General Manager, Head Enterprise Risk and Corporate Resilience, Bangalore International Airport Limited. Then we have Dr. CVR Murthy, Professor, Department of Civil Engineering, IIT Madras. It's my personal pleasure to welcome you, Dr. Murthy. Thank you so much. He'll be talking about getting started with pilot projects of earthquake retrofitting in Indian industries, something what we are looking at from a FICCI's perspective, a CIDM perspective, to go on a project mode. And I would request Rituraj ji from Adani that, this particular presentation, I would really, after this session, we will have an offline discussion of how we
Yeah.
can get into a pilot project mode of executing some of the things which will be discussed during this session. So one of the reasons why I'm really pleased that you are chairing this session. Then Dr. Chandan Ghosh, a very, I call him my mentor, I call him my friend as well. He's always a delight to be around with. He's a professor, Department of Civil Engineering, IIT Jammu. He'll be talking about traditional and nature-based footprints in earthquake resiliency, something which has been really admired by all the speakers and all the his fellow speakers and all the participants in all earlier conferences wherever Chandan Ghosh Saab has spoken his mind. I think it's been very well admired and appreciated across the board. The fourth is from Shri Yogesh Bharat, who's the National Head Customer Service Group and Marketing of Prism Johnson Limited, RMC India Division. He'll be talking on earthquake resiliency, structure, ground reality, and case studies. So, gentlemen, we will have 15 minutes of presentation time. I know this is a short time, but with your expertise and with your aura around during this session, I think the message will be through in those 15 minutes. Before I hand over this to the I would say the mic virtually to Rituraj Mehta ji, I would request Menak Mojumdar to make an introductory remark on what we are looking forward to in this particular session, and then over to you, Rituraj ji. Menak.
Yeah, thank you, Bob. Actually, this particular session was thought of because the Indian subcontinent has suffered some great earthquakes of magnitude 8, and even moderate earthquakes in India continue to cause these deaths, which indicates some poor seismic resilience of its built environment. We do have codes, we have building laws, yet there is a need for proper inspection of health of existing buildings. We need to assess, we need to evaluate and do the necessary retrofitting. There are examples of, pagoda type of wooden houses in Japan, some old Assam type houses in India, Koti Bannal type of houses in Uttarakhand in India, which reminds us of technologies which can be used for earthquake resistant structure. Basically, critical infrastructure of any country is the backbone of economy and is extremely important to protect it. Hence the need for this session on earthquake resilience, case studies and importance of retrofitting. Thank you.
Thank you, Menak. So a few lines on introduction on Rituraj Mehta ji before I hand it over to him formally. As I said, he's the corporate head of safety and business excellence in the Adani Group. He also is he's a corporate professional in the field of safety and business excellence with over 26 years of experience and exposure in major industrial business sectors like automobile, chemicals, textile, cement, energy, and financial services. He has worked with renowned business brands in India like Aditya Birla Chemicals, Grasim, Ultratech Cement, and now with Adani Power. Having started his career as process engineer, he has wide experience of various functions such as process, production, change management, safety, and business excellence. So I think on that note, everyone is happy to be in your hands now, Rituraj Mehta ji, and please, as the chair of this upcoming session. Over to you, Mr. Mehta. Thank you.
Thank you so much, Mr. Rubab, for your kind words, and happy to be here. Actually, and good morning to all again. As has been shared by Mr. Rubab, that this particular topic of the webinar, which has started yesterday and today is the second day, is such an exciting subject that number of participants was and responses received was so much that I guess the website got crashed, and then we again had to start, and then because when this idea was coined few weeks back to me from FICCI, and I was also excited that this is very critical subject wherein we need to do a lot more from our side as well. It is not only the responsibility of government and government bodies, but also from the industry perspective. What are our preparations? How do we see to it that in such cases, what is our response, whether it is part of our emergency response plan, whether we have internal capabilities built with our team to respond appropriately in such cases, whether we do have some systems to early detect these kind of scenarios so that we can respond in proper manner. With those kind of ideas, when I discussed this with FICCI team, and I found it to be very useful, and I was rather I would say I was excited to be part of this webinar. And today's session, of course, is very important, and I look forward as a participant. Rather, I would say such eminent personalities are there in today's presentation, and so many interesting topics are covered. Being part of a group which is majorly involved in infrastructure business, as has been rightly explained by Mr. Rubab, that we are there in rail, road, metro, power, transmission, and now airports also. So I'll be looking forward certain learnings out of this particular session, and I'll also note down certain things, and I would request participants to go through very seriously and note down certain things which will be very useful for us, for our respective organizations, in order to implement and see that things are done. Interestingly, those presentations have the topics which are actually from the ground only, and certain topics are there, especially retrofitting kind of pilot project, which I would also be looking forward to learn and see that how it is implemented. Airport also another case which I see that interesting case for us. So I see this as a wonderful forum. Thank you so much, FICCI, for creating such a platform, and I look forward to have many such more topics in future, which is actually useful for us as an industry. Now, as you all know, we have 4 presenters today, starting with Dr. KJ Devasya. Before inviting him, I'd like to introduce him to this forum. Dr. KJ Devasya is one of the well-known faces in the national and international arena of crisis and continuity management with more than 20 years of domain experience. He is currently heading the Department of Enterprise Risk and Corporate Resilience at Bangalore International Airport Limited, the 3rd largest, we all know, in India, with the direct responsibility of disaster management, business continuity, risk management, and airport medical service, and heading the COVID-19 task force at the airport. Prior to this role, he worked with UNDP, the World Vision India, and Pratichi India, Trust of the Nobel Laureate of Professor Amartya Sen. He was a recipient of Karnataka Chief Minister's Meritorious Award for Outstanding Contribution to Civil Defense and Disaster Management in the state, and also the winner of Continuity and Resilience Professional Private Sector India 2017 Award by Business Continuity Institute BCI UK, and nominee for the Global Award under the same category. So let us welcome Dr. KJ Devasya for his presentation. Welcome, Dr. KJ Devasya. Over to you.
Dr. Devasya, you can share your screen. We have allowed.
Yeah.
Yes, we can see you, Dr. KJ Devasya. Welcome again.
Thank you. Thank you so much, Mr. Ripul Raj. And it was very, very detailed introduction. Probably it is larger than my presentation, I believe. And it's so nice of you introducing me in such a way. Thanks a lot. And when I saw the speakers list, I thought that I should not prolong my session, because we have Mr. Professor Murthy and a couple of other, including Professor Ghosh and everybody. It's a very, very brilliant speakers panel, and where what I am going to say, I should actually learn from them. That's what my feeling right now coming in. Anyway, I know it's still the topic which is given to me is something which is different. It may not be very exhaustive in terms of technology or retrofitting or anything of like that. It's mostly of operational continuity in case some earthquake or something of similar nature happens in Indian airports, how we can tackle and what should be the way forward. That's a topic which is given to me, so I will just stick to that area only. I will not go beyond that. Let me just get into the backdrop of Indian civil aviation. It is nothing secret, or it is nothing unknown to anybody. Mostly it's all in the public domains or websites and things like that. As you know, we have 125 airports in our country, operational airports. Okay, and in this 125 airports, we have a large number of airports are international in nature, where flights are operating from here to different parts of the world actually. And the standard what we all need to, or I can say that the pressure which comes on the airport operator regarding particularly for keeping the safety, security, and the resilience in place, it's a tremendous. Okay, because we have to match with the international standards, we have to meet the customer expectations, and also we have to meet the standards which are laid down in our country, multiple different standards. Half a dozen of ministries we are coordinating, particularly for coordinating for resilience and the safety measures at the airport. So, you know, while I say all these things, there are certain kind of things like we are again governed by certain bodies, our Civil Aviation Ministry or the Director General, Bureau of Civil Aviation, particularly for the security, while the DGCA is meant for the aerodrome standards, safety and things like that. The civil aviation security is basically mandating the security aspect precisely, and over and above we have the International Civil Aviation Organization. So mostly Indian, not only Indian airports, every airport in the world, and particularly in Indian airport, these guidelines issued by multiple agencies has to be followed. And I can say there is actually a set of measures in place while an airport is getting established. Okay, so some acceptable standard of resilience or redundancy is inbuilt in every airport, both in infrastructure as well as in operational matters. That's having said that, I should again acknowledge here, or I should say that accept that still aviation is mostly giving highest emphasis into aircraft related crisis management, not anything which is beyond that. Anything else is coming. We have planned procedures, systems, everything in place, but the highest stress or emphasis is always given to an aircraft crash or aircraft hijack or anything pertaining to that one. This doesn't mean that other areas are ignored, other areas are well taken care, but we need much more to do in that area. See, I know in the participant list, there will be a large number of aviation professionals also, I expect like that. So, okay. So what I would like to communicate mostly here in this platform today, that the risk tolerance in the aviation and also the risk appetite. Okay, so if you are having a robust crisis plan or resilience plan, your recovery time objective should ideally start from 15 minutes, if not less than that. That's then only you can meet the requirements envisaged by or laid down by the international bodies or the government of India guidelines. And most of these things are not organizational. When I say 15 minutes, it's going into departmental, functional, or a process perspective. But when it comes into organizational recovery time objectives, mostly it's of 1 hour or 2 hours or something like that. So the tolerance level is literally, it's a zero in airport. You know how critical is an airport industry or an aviation industry is for the from multiple perspective. Probably in the coming slides, I will try to establish or try to explain some kind of aspects towards that one. Now, while the risk tolerance is supposed to be zero or expected to be zero, the risk appetite, when it comes into, there is variance across the operators or the people who manage it actually. Okay, mostly sometime back, if I say some 10-15 years, at least 10 years back, airport was only meant for air travel. Today the story has changed a lot. It's something different. It's actually a different city, it's a different world, and the people simply come there to hang around or just to hang out or just to enjoy the life there and go back, not even flying. That kind of a nature is there in airport, and the privatization of the airport or making a lot of facilities in the airport has added a lot into that one. When such kind of expectations are there from the customers or from the passengers or from the airline community or international fraternity, then the appetite, risk appetite has to be probably redefined by everybody in the Indian scenario. Particularly Indian aviation is booming like anything, you know that. 20% growth before the COVID happening, 20% growth was there with the overall. Now, of course, COVID has changed certain things into, but irrespective of that, we are bouncing back, and we can expect a similar growth in the coming years again after 1 year or something like that. What is important point when I say aviation is a kind of holistic approach in resilience planning. We need to cluster all kind of crises where not only aviation specific or crash related or something like that, but other sectors also needs to be clustered, and resilience plans needs to be there. The bullet points what we can see on the screen, where line number 2, non-aviation or non-aircraft related, where comes earthquake or any other kind of a natural disasters where attention required more in the given scenario. I can say if I go into the number of earthquakes happened in the past across the globe and the impact on the aviation industry, particularly airport industry, it is so many are there. I don't want to go in all those historic data, but I just want to highlight what is actually going to happen if an earthquake is happening. Unfortunately, something occurs, something like that in our region, and what kind of loss is happening and how we can come back quickly. Is it possible so easily? Mostly the airport infrastructures are coming in two or three area. One is obviously, the runway. Without the runway, there is nothing possible in an airport. Second thing, obviously the airport terminal building, and that's the processing area, or every interface happens there. And obviously this all controlled by an ATC tower or an ATC air traffic unit, and that's also normally a bigger structure, critical structure. Okay, so probably we have never thought of the magnitude of impact which can occur in case earthquake happens in a region and the airport is getting impacted, and it's not that easy to bring it back very shortly or something like. And moreover, I should say that this is one of the national assets. Airports are normally a national asset, whether it is a joint venture or whether it is run by the government. Ultimately, it is gateway to that part of the country or that or even to the country. Okay, and having that facility even for crisis is very critical, and it can make bigger changes, and probably a disconnect will happen in case an airport is getting impacted. But the reality is that many airports in our country has never thought of this impact or never taken this with the due seriousness, and the planning or the preparations are not done in such a way. Other aspect of an earthquake which you can bring into aviation, particularly airport industry, is again operational challenges. Okay, now if an earthquake occurs, thereafter the structure remains, still nothing can be happening there because the flight cannot take off from there because of multiple reasons, and customers, passengers coming to the airport are numerous, and they all will be stranded there. And the reason is a very critical, because they cannot move from there to the destination. They cannot go back to the city, and the airport again become a place where refugee, I should not say refugees, actually maybe a rehabilitation or a relief locations or something like that, people have to stay back there. That's another challenge which airports are going to face. Suppose an earthquake occurs, thereafter a lot of infrastructure, if not major damages happen, and we need to get back to again a business continuity mode, then it's at least a couple of weeks or days we have to work around, then we have to get back, and it's again challenge going to be. Even after bringing the basic infrastructure back to operators, still it is challenge going to be with the employees. People will not be available to run the show there or to operate the airport, because mostly the employees also are victims or people who are getting impacted, and we need the support of the different types of militaries or different types of forces from the government sector, so that the basic operation can be retained in order to ensure at least the relief activities or the crisis response activities. Okay, so looking at the impact in an airport, an earthquake can create, it is various, and unless you are having better plans to handle that, not only a simple continuity plan, but a very robust resilience plan, it can again create logistic issues. Okay, I should not forget to say that if I already said it again, airports are actually gateway. That's actually the place where most of the relief activities getting coordinated. That's the place where materials, material, or even relief equipment, relief team, everything is getting moved from one place to the other. That's all happening through the airports normally, and the impact can happen in that area. So that's one relief activity coordination that's impacted. Second thing, the airline industry. Again, hundreds of aircrafts are booked by the domestic carriers or Indian carriers, and where they will park in case some major issue happens, and that's another challenge. Airport itself is not worthy to park them, but they have to take and park somewhere there, is another issue. Then the cargo movement, a lot of perishable cargo, critical cargo required at the time of the crisis, which again getting stuck there due to the disaster or earthquake, which stops completely the operation of the airport, and the connect between the airport and the city is again very significant area. So multiple way looking at the impact is infrastructure specific, the impact is a logistic area, the impact is an operational area, and much more than that one. But Indian aviation industry, probably the airports have never done a very holistic analysis or very robust planning to mitigate issues pertaining to earthquake in the region where these airports are located. Okay, so if I just come to summarize my viewpoints, what actually the requirement? One issue, the due attention to the seismic mapping or seismic zoning, or even the measures needs to be taken in those zone 3, 4, whatever, wherever it's actually, that is not going into the airport planners or the people who manage that even probably that require. And to substantiate that, even the seismic mapping also, I think even now we follow 2014 map, I believe, and a lot of changes are happening in India. Growth is happening like anything. Huge projects are coming up. Okay, so the change happening, and that way the seismic mapping and zoning also needs to happen, and that implementation also in that area in tandem with the aviation requirements again. Another thing, while the infrastructures are growing like anything, the industry is booming like anything, and a lot of iconic structures and projects are coming up, even we need to look around the way the buildings are constructed and whether that's sufficient too. Now, the National Building Code is a very, very elaborate document for us, but a certain area when we look at for infrastructure like a terminal building, we need little more beyond that. Probably little more specification in the aviation specific area has to be there. And in the current scenario, we are again depending to some extent the NFPS standards also, because the NBC is not sufficient to make a certain iconic structures in the airport campus or things like that. I know Professor Murthy and other panel speakers are there. They all are actually working on this line mostly, but still I thought it needs attention. Therefore, I'm just putting it across here. Way forward, if I look at in this 15 minutes, a short summarizing of the earthquake versus or interface with the aviation industry, few things come to my mind. One, seismic study of Indian airports. Okay, we have structures existing at least for some 40 years, 30 years, or even beyond that actually, which has not changed, no upgrade happened in a considerable manner. Seismic study of the airport infrastructure, particularly the tower, the terminal building, or those kind of thing needs to be probably initiated now, if not done by anybody. That's one important area I think where we have to focus. Second thing, risk management or risk assessment. Okay, now my regulatory bodies are asking for certain basic or unacceptable level or a minimal level of risk study and activity, which is anyway happening, but that's not enough. I already said some time back, airport is no more simply a location where people fly in or fly out. It's actually a place where huge number of people coming for multiple businesses. Okay, so we need to do holistic risk assessment, risk study, and mitigation measures that also should be with a commitment that has to be implemented in every airport. Why I'm telling that one? If you don't do that, one airport having an impact and air collateral loss or damage or something like that, then that's not the only airport suffering. The adjacent airports also suffering, though there is no impact directly happening. That's the reason everybody needs to do that kind of a thing. And other important thing, an integrated crisis model. In every platform I push it globally, also even to the Airport Council International. The Zylos. Some in the beginning also you heard it telling actually people work in silos or activities taken in silos. That needs to change. There should be a kind of integrated approach for risk management, crisis or contingency response, recovery, entire recovery activities, and the resilience model together with the business continuity as a single holistic approach, which is missing in an Indian airport sector, which is very important at this point of time. And that's again asking for a huge commitment from the management of the respective airports, whether it is a private joint venture or the airport authority or civil enclave, but we need to do that part. Second thing, even today, one of the challenge we see is actually, while everything else is given importance, the recovery continuity is not getting due significance in the airport industry. So we need dedicated team, professionals, highly qualified people to do the planning and implementation, mitigation measures and everything in terms of crisis response where natural disasters or any other kind of disasters are happening, that should be addressed. And again, mandating. Today, Indian governance system is not mandating a robust business continuity management model or a resilience plan in airports. They want crisis plan. They are actually focusing on the crisis response management, but a continuity, recovery, resilience, which is missing, that needs to be mandated by the authorities so that everybody will take it further forward, just like in the Western countries. Okay, and robust plan preparation and national level collaboration. Now, Indian aviation sector is diverse. We have airport authority, we have joint ventures, we have PPP models, multiple models are there, and also private small airstrips are there. Best practice sharing, and knowledge sharing and integration, a uniform model. All those things needs to be coming into aviation sector with a focus on the disasters which are not yet being given due significance, such as flash flood or earthquake or cyclones in those regions or wherever it is applicable. With this, I would just conclude my small capsule here. It's COVID time. Stay safe, stay healthy. Thank you.
Thank you so much, Dr. Devasya. I guess that was very interesting topic and wonderful presentation from your side. A few points what I noted from your slides was many of our airports don't have earthquake resistance infrastructure. And one bottom line I really liked in one of your slides when you said that, do you want to stick to the minimum requirement or best possible? That's a very important thing, and that is actually should be our approach while handling any kind of risk associated with our business. And another important thing, you talked about plan A, B, or C. If we don't have that plan available with us, I guess it is very difficult for any airport to recover after earthquake. And lack of proper resilience can also impact logistics. It's not only about the people flying here and there. Seismic study, holistic risk-based approach, and robust plan. I guess one more thing, what you, although it was not written, but I guess it is directly, indirectly shared, that capabilities enhancement is also one of the very important aspect of this, I guess, this subject. So thank you so much, Dr. Devasya, for this wonderful presentation. Thank you again.
Thank you.
Friends, we do have next presentation, very interesting presentation, as I stated earlier. The topic is getting started with pilot projects of earthquake retrofitting in Indian industries, which will be delivered by Dr. CVR Murthy, Professor, Department of Civil Engineering, IIT Madras. I guess Dr. Murthy doesn't require any introduction with such an eminent personality. You know, I remember my college days, we used to say that if you are in front of any professor, it is better you use lesser words and be quiet and learn from him. So I invite you, Dr. Murthy, please, over to you. Thank you so much.
Thank you.
So while you, Professor Murthy, while you put your presentation on the screen, I would request all the participants who are right now watching us, watching these presentations happening, if there are any questions they want to ask the panel today, they can just mention those questions in the question and answer window. We will take up these questions after the presentations are made before we end this session. We have a dedicated time slot for taking questions and getting answers from these experts, eminent panelists. Over to you, Dr. Murthy.
Thank you, Chairman Sab. The subject in focus for me is earthquake retrofitting in Indian industries, and I'm keen that we get started with some pilot projects. So I'll present today's thoughts in three segments: specialities of industrial structures, pilot earthquake projects, and then urgent steps required. On the specialty side, I'll begin with our classrooms. This is what we teach our students in the classroom. And when it comes to a project, we give them this structure. And if its structure becomes a little more complicated, we call it a PhD thesis. And when they graduate, some of them go a little more modest and do these things. Some people are a little more challenging, and so they give a twist to the whole structure. But in general, the set of people who go to building industries are more or less doing similar kind of work. But another set of graduates go and do something very different. And as you can see, your eyes are not having harmony here because there are various requirements in industrial segment, and they are in large sizes and shapes in different geometries. But one thing that comes out very clear from all of this is that when there's an earthquake, it's not really working well, actually. The conveyor belts don't work, the pipelines don't connect anymore. The support systems don't stand, and the roofing caves down. And all these are from the Indian industries during 2001 earthquake. I want to show these pictures from. There's also a concrete structures built. There are warehouses which look very regular and simple, but somehow our students forget when they graduate that there are items that they are putting in between, which are actually changing the entire behavior of the structure. And then there are collapses which cannot be repaired. We have to basically redo the whole facility once more. Some of them are in a great hurry and they would like to build precast constructions because you can do it in 28 days, 22 days, 21 days, and so on. But they forget to do the connections properly, and the connections are very feeble and not formal at all. Some of the others forget the dimensions that masonry cannot be stacked up to long heights and they will fall out of plane. And there are others who are economizing on the vertical members which are supposed to hold the entire structure. And these delicate darlings at some point of time will have some trouble holding up this heavy masses on their heads. There are also bridges which are just precariously balanced and they jump off from their plumb when earthquakes come. And there are large number of bridges that we have which over the years have been built, and their masonry and stone over stone doesn't stand during earthquakes, especially arches. Two sets of structures that we are not able to handle yet is oceans, coastline structures and hillside structures, because we seem to have disturbed the nature so much that the nature itself becomes a fury for us when the earthquake shaking happens. But what is troublesome is simple electrical posts. We are not doing it formally, rather informal in our way we are handling electrical posts. To talk about civic structures also, I think the water tank structures have taken a big beating because of the way we are designing and the way we are constructing with single curtain of reinforcement. And believe me, all this is to reduce cost. And cost has become such a menace for all of us. We forget life cycle cost when we're talking about initial cost. Simple pipelines are trouble for us, and we are not able to contain our water properly during the aftermath of the earthquake. So 3 observations from all this. One is that we're making highly irregular structures whose mass and stiffnesses are distributed randomly across the structure in industrial systems I'm talking about. Second is the level of engineering has large number of simplifications because when it comes to engineering, they remember classroom, but when they come to construction, they will do something which is required by the client. And thirdly, most of the structures are steel structures, and connections in steel structures are so crucial. And today, as we speak, there is no standard for giving you earthquake resistant design of these connections. And these connections are in different geometries, and most of them are reentrant, and they're done in a very, very ad hoc way. The industry practices a whole spectrum of connections, and we know that only the rigid set of connections are the ones that will survive during an earthquake. But what do you do with the remaining 90% or 80% of the connections that are already there in the Indian industry? We have 2 concerns also. Dr. Devasya also emphasizes clearly that the hazard has not been estimated correctly, especially the acceleration hazard. But to me, there's another hazard that's not estimated at all, and that is displacement hazard. Let me explain both of them. Normal buildings, we have to design for a certain hazard, but when it comes to industrial structures, we have to design for almost 3 levels higher hazard than that. And when it comes to even specialized structures, we will have to design for a much higher level of hazard. And this observation, this approach is not yet been there, not put in the Indian standards yet. So this comes out of the fact that different clients require different levels of performance and they have different levels of affordability. And that is where we have to change our methods of design to suit the requirements of the client now. If you look at hazard at a site is fixed 0.8 G. But if you're building buildings, you will take only 15% of that. If you're building important structures or hospitals, you might go 20-25%. If you're building critical facilities and industries, you will have to go much higher. And if you're building nuclear power plants and dams, don't tell lies, use the whole hazard. No need to reduce the hazard in lieu of probability. Don't talk of probability when you do such structures. So this whole concept of probability has to be understood rather more deeply by the industry and not take chances, because each day's downtime is 300 crores, 400 crores, while the initial incremental cost required to make it earthquake resistant may be just 1 day's downtime cost, 300 crores out of an investment of 1800 crores, let us say. Look at industrial systems. They come in many, many subsystems. Any one subsystem fails, any one link fails, the game is over for us. The second aspect I want to talk about is the displacements hazards. the pipelines for crude oil and LPG, at least 40,000 kilometers are there, and the pipeline for water supply across the country is about 1 lakh kilometers or more than that. And all these pipelines are crossing a large number of faults, and the design for this has to accommodate the fact that we don't know where the fault is. The fault is approximately known, but exactly not known. So it's not a line, it's a region. And so you have to allow for a large number of possibilities of where the fault is. And so keep bending this pipe in either direction, allow flexibility. When the earthquake happens, it can move this way or that way. We don't know where the fault is. So over a large region, you have to put extra lengths of the pipe to make sure it doesn't fail. Dr. Devasya was asking for revised hazard. Yes, we are almost there. And what we are using today in seismic zone 5 is 0.36 G. And soon around the corner, we might have to push ourselves to a much higher level of hazard of 0.6 G. This is going to be our near future, and we will have to redo our structures, especially the industrial structures once more, examining whether that is going to survive this higher level of hazard. The higher level of hazard is not because this is suddenly new things are happening in the earth. No, the past map was made only on past earthquakes, but this future map, the new map, is being made on the projections of future events likely to happen in that region or in that tectonic area. So, of course, the industry has only one expectation. They want business continuity. For that, the design strategy is to have no damage, which means you have to use higher level of engineering and you have to spend much more money at the beginning. Talking of money, if you spend more in the beginning, you'll have to spend less later on and vice versa. But what's interesting is you look at the life cycle cost. For the same total cost, you will get two structures, one on your left side and one on your right side. The one on the right side will have collapses and one on the left side will not have collapses. It will have some damage possibly. What is crucial is that which way are you designing? For reducing cost, initial cost, we are going to the right-hand side, which is not acceptable for an Indian industry. And you have to choose the path to the left, which is closer to your heart, that you will go with as the basis for your design. I must mention here that if you spend 100 rupees on the industry, construction of the industry, 20 rupees will be on your structure, 80 rupees will be on finish. The number can change a little bit, 30, 70 or 10, 90, depending on the type of industry you have. But what is more crucial is the land cost is much, much more, orders of magnitude more. And hence you have a total cost of, let's say, 1100 rupees, including land. What is interesting is for making it earthquake safe, you have to add only 4 more rupees out of 1100 rupees, which is 20% of the structure cost, 20% of 20. And this is not going to change your economies during the profit margins that you're talking about. No, it's not going to change at all. So my pitch is be wise and pitch for a higher initial cost with lesser damage in future. Otherwise, your recovery time is going to be so large. I'm just saying 3 to 8 months, but it can be even into years, which can break the backbone of your financial strategy. So it is crucial for us to not get into a situation where to begin with itself, the demand is higher than the capacity, and the earthquake just reiterates that. We can't do it after the earthquake, we have to do it before the earthquake. So normally a structure will keep deteriorating, and if you do retrofit on that now, you will be saved, because when the earthquake comes, the entire structure will be lost, the entire business will be lost. If you do retrofit, you will be able to continue your business. Today, we have large number of structures that are unsafe, and we need to make sure that slowly we replace many of them with retrofitted structures, or repair or retrofit some of them and replace some of them with earthquake resistant structures. If you look at the national mandate, the National Disaster Management Guidelines for Management of Earthquakes says that selective seismic strengthening and retrofit of existing priority structures and lifeline structures has to be taken up by us. And it has also provided us guidance on how to go about doing seismic retrofitting of deficient buildings and structures in this country. I'll go to the second segment, pilot earthquake retrofit projects. Believe me, retrofit comes in different sizes and shapes. People will sell repair for retrofit. You have to be very careful. Unless you have technical professionals on your side who understand the difference, you will be easily fooled by any of the commercial vendors who comes to you. About cost, yes, you will have to decide what will be the downtime, what will be the consequence, and allow for a slightly higher cost than normal buildings and structures when it comes to retrofit. As far as methods are concerned, two parts in the whole work. One is global retrofit. Second is local retrofit. You have to do the global first and then go to local retrofit. In global, we're talking about overall lateral strength, lateral stiffness, and overall deformability. So if the earthquake comes and imposes a demand less than the capacity, you're okay. But if the demand is more, you're not okay on your structure, because earthquake is displacement loading and not force loading. So you have a choice to make a red structure with damage, large damage, or you make a green structure with no damage or less damage, or much more elastic behavior. Choice is yours, but the cost difference is not going to be too high. And that is the game that you have to get into. Talking about retrofit, if you're looking at, the first thing to do is fix all the obvious items which are missed from classroom days. And the second item is to make sure that the lateral stiffness in the direction of shaking in both directions is improved, either by braces or by walls. You can do it. But sometimes you'll say, no, this is vulgar solution. We don't like it. So obviously you don't like it. We know that. And so we have an option for you that when you can't touch a structure to retrofit, you have to do something to protect the structure. So this is like parenting. You have to do some parenting of this structure. Have the mother and father on both sides hold that structure together without allowing it to shake too much, right? But what is crucial is many of our industries are located in land that is easily available, and that's not necessarily the best because we have large amount of flooding that is happening. So this kind of items are not coming into retrofit, but don't do earthquake retrofit if you don't have, if you haven't fixed this problem first. Coming to local retrofit, you can do vertical member local retrofit in industries, but the horizontal members will remain a challenge because there are large spans, and increasing the mass and weight of these beams is not going to be so easy. And so local retrofit by mere jacketing alone will not be the solution for us. We have to start global first and then only go local, because the connections can never be fixed in local retrofit strategy. There are different levels of assessment, level 1, 2, 3, 4. One is a rapid, second is detailed, both are qualitative, third is simple, quantitative, and fourth is detailed. What I'm recommending is a third level, level 3 assessment of simple quantitative assessment, so that you have a basis and go forward with retrofit. Don't look for the perfect solution, make an imperfect start. Very clearly, if you have 1 lakh structures in the Indian industries to be taken up in this decade, you will notice that after level 1 screening, you'll need only 10,000 to be taken to level 2, and only 1,000 to level 3, and only 100 to level 4. So we should be able to take up this challenge of retrofit in a much faster pace if all our industries are able to participate. But I know that all will not participate. So first we have to inform them of the process, how to do the retrofit of our industrial structures, and then launch what is called a model industry earthquake retrofit program. What am I saying here? I'm saying I can't fix all the industries on the same day, but we can do a select set of industries today, limited number of industries. Learn what is retrofitting, document what is retrofitting, and then showcase to everybody. And that is the proposal here. We need 3 volunteer industries in 2020, 1 small industry, 1 medium industry, and 1 large industry, so that all sectors will say that, yes, we have gotten started, and they will have to implement retrofit in their structures. Whatever be the deficiency, we can work on that, and then document the same in detail so that others will be able to understand in simple terms what is retrofit, and then showcase it after the retrofit is over, bring people and have an organized activity to showcase that, yes, we have done retrofit and this is how we have done, and this is simple. It is doable. So my request is to make an imperfect start, retrofit a small structure first in your own campus amongst these 3 volunteer industries, establish the procedures, and then embark on the larger and larger structures and complete all your structures on your campus in about a limited, on a set time frame of 5 years, 10 years, whatever, depending on the size of your structures. So the urgent steps that we have to take is that, first of all, we have to have a noble business agenda, which is mitigation. And retrofit is the center space of mitigation for the Indian industry. We need to put in place systems and processes So the persons to do retrofitting are the competent structural engineers. Don't take 21-year-old boys and girls to do retrofit. Not permissible. They need to go through rain and shine, day and night, enough number of times to understand what is structural behavior, and then only you'll be able to get them to do earthquake retrofitting. Second is that you need to have a focused program of improving competence of engineers in your industry. Currently, since no college teaches this subject of earthquake safety at the undergraduate program, except 7 colleges of the government of Gujarat, I would say the graduates that are there are self-taught on the subject of earthquake safety. And this is not the way a nation should work of 132 crores. We need to have a competence building of engineers, a capacity building, and then in that program, we need to focus on hand calculations and not computer calculations. We need to inculcate in them intuition of structural behavior in them. Nonlinear analysis is not taught in any college in the country as the mandatory curriculum. And hence you have to get their tools improved as part of this capacity building activity. This is a very, very crucial subject. And then finally, you will need to reach out. I'm even going to the extent of saying, get your adversary, your competitor also to retrofit his buildings and structures, because I'm very confident that we'll need every industry to work, because Indian population requires so much of men, material and matter to be active, engaged, and we should now be able to export all our products to the other countries. So I want every industry, no competition in this game of retrofit, it's partnership in the game of retrofit. In closing, I will mention that today I don't know where I stand in the Indian industry, or whether my structure is unsafe, not safe, unsafe, or safe. I don't know where we stand, because of the practice is self-driven. But what is crucial for me is I spent 10 years worried about industry and automation, another 10 years on quality, another 10 years on innovation. My question is, will 2020s be the watchword, become safety for us at the Indian industry? That is what is my pitch. Please pick safety as your driving seat, and then only you'll be able to do earthquake retrofitting. What's crucial for me is think of a gentle ramp, think of a long-term program of retrofit. Internationally, this is what is seen as viable, and not shortcuts. There are no ladders in this game of retrofit, right? And that is what I'm saying. Patience is the key for all of us. It's time to get into the play field and not become just a mere spectator. We have done this for 73 years. I think it's time to get into the play field now. I know for sure that even if you get started, you will be the only one. And don't worry about that. When they see your successes and when they see your gains, some of them will change their mind, and maybe they will join you in time ahead. And then you will see a larger movement. Kafile judte gaye, karwa badhta gaya. That is what I'm expecting. And Rabindranath Tagore said it nicely. Jodi to dakshune keu na ashe, tobi akla chalo re. I would like to see that our goal is to improve your industry and distinguish yourself from the others, and come out of that red ocean strategy of competing and get into a blue ocean strategy of doing things happily and enjoy yourself. Because I know that this man will not come again to give us retrofitting solutions for this country. He is not going to come, and there is no Santa Claus that's going to come to give us retrofit for the entire country. And we are our own Santa Clauses. We have to do our work ourselves. If in my last 15 minutes I've managed to touch the attitude aspect of retrofitting, I'm sure that skills and knowledge will be learned, because attitude is the way of thinking or feeling about something or someone, and it's to do with your heart. And you will pick up skills, the ability and capacity to do sustained systematic effort over time with your hands, and you will pick up knowledge, the human capability to interpret information. It's to do with your head. I'll stop here by thanking FICCI for giving me an opportunity to speak before you here, and especially Lieutenant General Bharadwaj, Rubab Sood, and Mainak Majumdar. Thank you so much, ladies and gentlemen, for your time and attention.
Thank you so much, sir. That was wonderful presentation. I could note down so many things. I guess I would not be able to explain everything here, because you only took 15 minutes, but the learning we noted down, I guess it would take more than 15 minutes for us to explain. But major points what I covered there was, you talked about irregular structures, level of engineering, steel structures, connection specifically for in that regard. Major concern, two types of concerns: acceleration hazard and displacement hazard, and current mapping as well as future mapping 0.36 to 0.60 G. We also talked. You also talked about specifically. We forget the life cycle cost as far as industry is concerned. I guess that is very important aspect. We used to practice those things mid 90s, but nowadays nobody talks about that. I agree with that. And then business continuity is also about no damage, and recovery time should be between 3 to 8 months. Vulnerability is something you mentioned, and interestingly, we are also practicing, but not in that form what you have explained. We are practicing it for past 2.5 months in our industry in power and transmission business. I would like to discuss with you in detail post this session. Retrofitting, you talked about global and local kind of retrofitting. Parenting of structure is one thing which was very interesting for us. And when we talked about vulnerability, rapid, detailed, qualitative, quantitative categories were there. And another important aspect, terminology you used about model industry earthquake retrofitting program, MIERP. I guess. And then another important aspect you talked about is competence of engineers. That was, I guess, a very important aspect, because when you said that only 7 colleges are having that kind of program available in Gujarat only, and that is very less amount, as well as I guess you didn't directly said, but the quality of the education of those people, those colleges is also in question. So we need to look at that. Thank you so much, sir. Thank you. That was a wonderful presentation. Our next speaker is Dr. Chandan Ghosh, Professor, Department of Civil Engineering, IIT Jammu. The subject is traditional and nature-based footprints in earthquake resiliency. Dr. Chandan Ghosh, we welcome you, and since time is very less, over to you. You can start your presentation, please. Welcome again.
Okay. Thank you for giving this platform, especially CIDM under Lieutenant General Bharadwaj, and of course his young brigades who will never be old, I know, Rubab and Mainak, and all others in the FICCI. So it is always an opportunity to go to the industry. After all, what we do or teach or study or research in IIT, we have to go hand in hand with the industry through projects and through knowledge that which we earn, and we have to disseminate it. Professor Murthy has nicely, of course, no words is enough, like Jodi tor dakshune tor keu na ashe tobe ekla cholo re. Good. So my part over here is some of the typical examples that I have taken. Knowing well that earthquake happens 20 kilometer, 25 to 30 kilometer below, but not only that, we have to be careful about this substructure, also superstructure. Mostly substructure part still remain in an enigma, that which is very complex to model even with a computer or any software, which Professor Murthy mentioned, non-linearity, that which happens, which often we do not. We are not having that much ability to take care of those things, which is very complex. And whatever earthquakes are happening across the globe, in civil engineering professional practice as well as in research, we have e-defense, or in our country also number of shake table where we can generate those earthquakes which are recorded every second, every moment, to test even here 2-story building, but also even 5-story, 6-story, 7-story building, to learn and relearn that which connection went wrong, which connection is well performed. So there are a number of such test videos are available. I'm not going into those because of the time sake. So just this is a scenario that IIT Jammu campus, that if you go 20 kilometers from this side, you will see that Mata Vaishno Devi temple, the Katra. So what we expect these days, we are all having mobile phone and everything. And we expect that everything mobile will supply or our watch will give us all everything. Everything we want is smart. But in order to do or get these things in our smart watch or even smart mobile, we have to spend a lot and we have to do a lot of hard work, which some countries has taken the lead. We are here to take it up. Or else, if we don't take, at least we can make a safe, like such a sturdy box, which are there in YouTube. You can see the moment earthquake is going to shake, it will close and there will be food items and everything will be there that can be kept there safe. So there are so many things are available in the market also. And there are earthquake bell like electric door calling bell, earthquake bell also available. But for that, whatever is the groundwork, wiring work that to be done, that has not yet catch up in our academia research industry. That is what I wanted to highlight. But when from disaster management, if I take the data from the 2019, last year, and the figure which will be familiar to you now, every year for the last 30, 35 years, these databases are coming up, being compiled with the organization. So number, you can see, I don't have to repeat, just last year. Every year it is being appended and we are getting more and more damage. But when I said that it is a nature-based solutions, and that our life of city that we are doing, it is nothing about the earthquake, but the city that we are living, a lake water cleaning in a month's time. And you can see that cost less than 3 lakh. This is the lake water that we create because we cannot clean it by our conventional technology. Within 30 days, it becomes so much mirror-like clean. So nature-based solution, it is not only focused on earthquake, but the nature has given us to make our living really wonderful. The way that we should live, we should go back and check back to the nature that what wonders that it has given. Not only that, even such kind of things also, floating geolog vertebral trash boom in Kolkata or many other places now, lakes, wastewater are being cleaned. So nature-based solutions, it is not only in earthquake. I will go to the earthquake, just wanted to show that there are many such examples. The first time that I want to take a Koti Banal house here in Uttarkashi district, which is famous for earthquake, 1991, and several times because the main central thrust is there. And this still survives even as per record and documentation made by Piyush Rathela, Girish Joshi and his team. They have made several publication documentation of this. And in World Encyclopedia for Housing, there is a paper is also there on Assam type house and for this kind of house. But details are available that how even 900 years back, they have ensured earthquake safety by providing some base and some things. I'm not going into detail, but details are available in the paper. So these are still surviving. Not only that, the records that you see, 1906, Koti Banal dwelling succumbed, that earthquake of 1905, which is showing here, that which is taken from a paper by Roger Wilhelm, who is famous for this kind of reporting. As in the first slide, I have shown that we want everything in the mobile phone, but at the same time, our natural mind always see that why this nature behaves in this manner. So what kind of inspiration or inspired thing that we can bring into our technology so that we can bring some kind of early warning or information into our way of being, which is to be brought in the smartphone. So there are several scores of researchers are doing, reading their mind, adding them, some tagging them, their behavior and other thing. Inexhaustive work is going on, why they behave in this manner or why they come out. But studying these things from their way, it is still far, but still lot many parameters are being appended to know the future of the earthquake. But at least we do not know when it is going to happen. But at the same time, even in 132 AD, this was the analog thing, that when there will be shaking like this, this dragon will drop the ball. That was the kind of inspiration long in that year, in the analog way, we could get and we could see and sense that how earthquakes are measured. Until and unless we do that, we cannot obtain or things that we can bring in the mobile phone. But what is coming in the mobile phone is a global seismic record, USGS shake map, even India also. All data is being accumulated, and we can show within few minutes of time that an earthquake that has happened, that what are the, how it is spreading. All these things are available as an information. We can see these things every day, every moment, every second. These are getting updated in Google Earth, and there are many seismic monitors are also there. So now coming to the nature-based solution or the people, the local or vulnerable structure, there are many footages and footprints are there. This is a typical Assam type house. For the last 200 years, people have been in the state of Assam and northeast. You can see there are architectural beauty as well as their proofness in the earthquake. We know, but which I mentioned, and this is in the northwest where I'm here in Jammu or Jammu Kashmir, Srinagar area, that is Thachi Diwali type of things, that which are solid enough, are resistant enough. We know them that they have been performing well, but studying them, putting them into the research mode, finding out that what kind of adaptation, implementation we can do. So we have brought in now the concept as well as theory, as well as performance of confined masonry, which CBRI or BMTPC and even IIT Gandhinagar and IIT Madras and many institutes have taken a confined masonry as an alternative, because we cannot use natural material like this. So otherwise, what buildings are happening like this, the corners without column, or even a new building after earthquake that happened yesterday, exactly 15 years back in the Muzaffarabad, the new building that which got developed crack in the corner because it didn't have any column. These things we have known. Or even Bhuj earthquake, before this was there. Now this after the Bhuj earthquake, this has happened. We have understood that there is a soft story or stiffness is less over here. But still, and these were there in 2008, Sichuan earthquake, but it has become like this after the earthquake. Or this was there, but they have become like this. All these features, right now we have talked about that there are many such buildings, that iconic buildings are still there, but they are one story or two story. And as I said, when we talk about the resiliency of the earth itself, in hilly area itself, where our entire Himalaya, there we make a lot of roads and retaining wall. But retaining wall, they are rigid enough. So there are many such technology came up that to reinforce the earth itself. So far we know RCC, but reinforcing the earth itself have shown that they become more flexible and they become earthquake resilient. So there are accelerated way of, we have to promote such kind of even earth structure with reinforcement where many materials are available. So earthquake resilient earth structure along with superstructure together, while designing or performance checking or health checking, rapid visual screening, we have to look into that to make the things check. So there are a number of such cases come in, even in 2000, many Supreme Court and many things are there. Let them remain in the on the written stage, but in order to implement things, or in order to that whatever we know so far, where earthquake happens, 8+ earthquake out of all these database, 8+ greater than 8+ magnitude earthquake is happening each year, and then 7 to 8 magnitude earthquakes are happening. There are many such statistics that have been taken, both instrumental plus historical records compiled by Roger Wilhelm and many other scientists in these. So 7 to 8 magnitude earthquakes, they are happening at least 20 to 30 in a year. Means every month 1 or 2 earthquakes are happening. So what we expect, whatever that earthquakes are happening across the globe and that which are being updated 24/7 with different color, we expect something like this to reach to our mobile phone. That strong shaking expected. So the red border, that which is traveling at a speed of say 3 to 5 kilometers per second, that wherever I'm standing with my mobile and GPS is on, location sensor is on, Arogya Setu and everything that we keep living on, Bluetooth on, everything on, it should reach us wherever we are with the kind of technology that we have. That we should be able to know that after how many seconds that earthquake, the red border waves is reaching us. That kind of technology have been developed years back, even in 1990s also. For that, such kind of work yet to take up. Of course, IIT Roorkee has been given a job to do these things, and one pilot study is under operational based on Uttarakhand, that in the IIT Roorkee campus. But we have to see that in the background that what are the work has to be done. So in fact, this last 2 years back, this is also installed, MyShake, strong shaking expected at the location that someone is having here in California, with 28 seconds of time will be there to reach this red color to this state, to this thing. This kind of information we need to have, but for that we have to work a lot. And 28 seconds doesn't make any difference if you are staying in a 3-story, 4-story, 5-story, but applying those things to stop a train or even many other emergency operations. You can think this is a live example. In 2004, 23rd October in Japan, they have stopped this train automatically by putting a automatic brake on the train which is moving in Japan. So that is the kind of things that 28 seconds or 10 seconds is more than enough to make the train, which is running at a speed more than 200 kilometers, to bring it that at least a derailment is there, but no such injuries and other things are there. Now coming to some of the things, that structure that nature has given to us, you can order such kind of buildings, 2-story. 1-story was there in Assam House. Making 2-story building in bamboo, something like this that has been made. Architectural beauty is wonder. For the industry or those who are looking at that, even you can see it is taken from the net, you can get the query also. So bamboo houses, earthquake resistance, that we know. There are a lot of research being done in our laboratories and other things. Implementations are also way, but an industry has to catch up. This nature that has given this material, especially about its connection, not by only architectural beauty, but the kind of measures that lighter, stronger things that which, stiffness that it has. We are yet to catch up into the earthquake resistant part more vigorously, rather than making it an architectural beauty as it is being shown. So we have to induce that. Industry has to come forward in this. There are a lot of because of the earthquake, how much we are vulnerable. These are all database are there. Qutub Minar, how it was affected. It is taken from from one of the famous paper recently last year published by Wilhelm and his group. And these are all being earlier. This was the publication, but now it has been updated in this manner, that due to the seismic gap, all this area, that how we are going to affect. We cannot just wait for that till another big shock of 8+ magnitude occurs. So these are all, 1934 earthquake, that even liquefactions and other things, ground modifications that we have brought into the research, but earlier it has happened in 1934 itself. Or these are the footage which you can see, the 1950 earthquake also in Arunachal, Assam, Arunachal and that border. So even river course has changed. So the footage that we had, the kind of resistance that these things give, we know by their performance, we know a lot of things. Only making one paper or publishing one thing is not enough. This industry has to come forward, promote these things rather than replacing the natural material. There are ready-made materials are also available, where implementation part is to be taken. As far as implementation is concerned, when you take about the pagoda, how they function in Japan, you can see these things, that how pagoda, the central mast, which they call it Shinbashira, the red colored one, how it is now being adapted to as a tuned mass damper in many buildings, especially Taipei or even this building. They have done these things for study like this, test it, implement it here. That is the kind of this in the Tokyo, that they have implemented, studied these things, and then implemented these things in this building, which is taken from the M. Oshira, Japan. So some of these things are seismically isolated structures with damping systems, structures with anti-seismic system. There are at least 10 plus number of such systems are there, which can be categorically adopted in our building to ensure earthquake safety. And these are all, the way that for last 500, 600 years, that how they have made their building multi-story. And all this Kyoto University. And you see that earthquake resistance of traditional Japanese wooden structure. I just wanted to show these things there. Way back in 1960, and they had a center which is still functioning, Disaster Prevention Research Institute, Kyoto, established in. And at that time, even such publications, such kind of things they knew, because we know that Japan is living on such kind of live earthquake. 1960, even our code came in 1962, but still we have many such vernacular structures in our country, many states defined by the tribe, defined by the way, and there is no such failure study or report that we can find, because of the nature that they are friendly with the nature as well as earthquake resistant. Many footages are there. So I want to say that, and the kind of connections and everything, they are being checked. In those days, even 100 years back, they're still functioning. So what now Indian standard codes and guidelines and BMTPC have brought in, study those things and make such kind of guidelines and regulations, which I want to show a few of the slides, components of buildings, then how, I'm not talking about RCC building or all those things, but how these are being adapted to make many of the vernacular buildings, even to this day, replacing wooden material by some other new materials, that manufactured material that are available. So these are all available in the BMTPC guideline. And these are all available even in our code, that how to make these things. These are the guidelines available. These are all taken from there. So showing that how a central, a reinforcing bar can help make even brick building also earthquake resistant. So there are many such promotions and conference, and then this kind of base isolated brick masonry building, even in here or other country. This is in China. They have been taken. Even in our country also, number of buildings are under construction or already constructed. But what is important is we often highlight is that the sub-story which we are making, without this we don't give municipality, we don't give even permission to construct the house, because parking is unnecessary. But when a 6-story frame building, plain frame building was tested, I have taken just a screenshot. Within 5 seconds, it is broken at this place. So it is experimentally also it is being proved that this is very dangerous, and we cannot talk much about these things because this is the way that we are living. Cannot do much on such kind of living, but we are still neglecting these things, and we do not provide in many cases even these red colored stirrups. So, but whereas the central beam and column connections also in 99% cases we do not make any perfections the way that it should be like this. So that is why talking about earthquake resiliency or making corners without column or column-like coloring sometimes makes it is very difficult to assess the health of the building, whatever guidelines or typology that we are having. So these are the sub-story that we often lose. Lots of our cars and all these things, and this also there. This is Bhuj earthquake. But we have some building even in Shillong also, or in Guwahati also. this is just 50 meters away from this place to this place, sub-story, but here a 3-story building having this kind of bracing where parking and everything is being facilitated. So thing is, even many of the sub-story building, it is taken from Professor Mukti's publication that red colored only fill up this portion by brick wall itself can save our multi-story building which are having sub-story. Even some of the structure, bridges, many things, they become out of operation due to the earthquake that which is faced. This is one of the examples. The 2011, 18 September earthquake in Sikkim, that which has killed not many people, but a lot of problem happened. One of the bridge, after 3 months, almost after 3 months, when it was carrying some instrument, heavy equipments on the bridge, it got collapsed because due to the shaking 3 months before, the bridge got some structurally some defect and some progressive failure might have occurred. We do not have any such facility to check that after earthquake that what are the deterioration, progressive failure, cracks that have occurred. That is a big area that when earthquakes are happening, many of our buildings, they lose their grip or their main connections and other things, which has to be checked. But it was not done, so we have to lose. So finally, I would like to say that retrofittings are being done here also, but it is not taken in that manner, the way that many other countries have taken up to prepare ourselves. It should be not like that, it should be aesthetic also. And so finally, it is in fact taken from the publication that I have mentioned by Wilhelm, Roger Wilhelm and his group, the death toll from future nocturnal, because you know, the earthquake, if it happened in the night time, Uttarkashi earthquake also happened in the early morning or even late night. So could possibly exceed 1 lakh death due to increased population in the vulnerability of present day construction methods. And despite the recurring social, economic and humanitarian cost, disaster affected population repeatedly fail to build back better housing to protect themselves from future hazards. So all these things are there in our guideline from BMTPC. This is all available, so you can go through that. Thank you. And before saying that, we should reverse the place or the house that we have bought in those areas. Yeah, in fact, I'm also one of that. The EMI that we are making, that we should make our future generation the EMI free, not just only by paying before we retire from our active service, but also EMI is there to make our safety of our structure. Otherwise, if we don't do anything, we just simply still going by the story, then we may be making a lot of stories and other things, and earthquake will make such kind of roles. This is very famous, that one earthquake that has created. Thank you.
Thank you so much, Dr. Chandan Ghosh. That was a wonderful presentation, and you gave a new perspective to this earthquake subject with having a nature-based solution. You also talked about floating boom. You showed Koti Benal house. Animal tracking is another aspect you touched upon and you talked about, which is helping predicting earthquake earlier. Earlier detection is one thing which you emphasized on, and also bamboo house and pagoda and so many systems you have touched upon. In the interest of the time, because we have already touched upon the next session time. So I again thank you very much for this wonderful presentation. A lot of things are supposed to be learned from that thing. A lot of structures are shown and how we can learn from the earlier when there were no technologies, how people were able to sustain their structures. Thank you so much again. Our next presenter is Sri Yogesh Barut, who would be talking about earthquake resilience structure, ground reality and case studies. Just a brief introduction for him. He has a vast experience, about 30 years in the field of civil engineering and cement and concrete. Currently, he is head customer service group and marketing in Prism RMC. He is a master's in quality management from BITS Pilani and engineering from Pune University. Executive education program he also done from Harvard, and senior management program from IIM Ahmedabad. And he is an alumni of IMD Switzerland. Without wasting much time now, I would request Mr. Barut to continue with your presentation. Welcome, Mr. Barut.
Yeah, thank you very much. Can you please allow me to share the screen? Actually,
yeah, please.
Sharing is disabled.
I guess, Mr. Rubab, can you help?
Yes, we have done that, Mr. Barut.
Yeah. Okay. Okay, so thanks to all for giving this opportunity to me to share my views on earthquake resilient structures, ground reality and case studies. So I'm really thankful to FICCI, NIDM and NDMA for organizing a wonderful technical talk, because this is very, very much relevant. Because if we see the failures in history, it has proved that it is extremely, extremely important to construct our buildings more resilient. And I'm very much sure that the people who have joined and who are watching this webinar are keeping themselves safe and keeping safe distance, because this also is very, very important for us to be resilient against COVID. That is very, very important. Now, friends, coming to this topic, earthquake resilient, why it is important? Because if you'll just see the guidelines given by NDMA, it is a compulsion for earthquake resistant structure. It is compulsory for every person who is constructing his building in zone 3 and above. It is mandatory rather, and it is 13 years, means it is 2007, June 2007 it was there. So it is 13 years old guidelines given by NDMA, wonderful guidelines, and I think people should observe that. And in that, builders, architects, and structural consultants have to answer in court of law if your construction or your structure is not earthquake resilient. And they also have given notification to Ministry of Finance that any bank who is giving loans to the big structures in zone 3 and above, they have to ensure that those buildings are constructed and earthquake resilient practices are carried out there. And if you also see the National Building Code 2016 also has given big emphasis, and they have advised all the engineers and consultants and who are involved in design to consider earthquake stresses, even if you are in zone 2 or above. It's not necessary that it is zone 3 and above, because if you see the 2001 earthquake in Ahmedabad, it was hardly in zone 2, but many buildings collapsed and the epicenter was even 350 kilometers away. So it is not necessary that it's only zone 3, but what I request is even any zone you are in, zone 2 or zone 3, we must ensure that our structures are earthquake resilient. That is very, very important. And one more reason why it is important to have earthquake resilience is, if we see our IS code 1893/2002, and very, very alarming figure, 59% of our motherland is earthquake prone. You just imagine, any part of your India, 60% of the motherland is earthquake prone. And if you'll see, there are 70% of the most important cities fall in zone 3, right? 12 crore buildings are there, 12 crore cities are there, where 12 crore, you can say, buildings are there in zone 3 and above, where around 70% of the important cities. And if you talk about the mega cities like Delhi, Calcutta, Mumbai, all are in zone 3 and above. So it is extremely important, wherever we are constructing, we have to ensure that earthquake resilience practices are exercised. And one more reason why it is important is past earthquake says that 95% of the lives lost is huge, alarming figure. 95% of the lives lost are not due to earthquake. It is due to collapse of the buildings that were not earthquake resilient. That is very, very important. So, see, though it is a 95% huge figure, but at the same time, there is 95% opportunity for us, for the people who are involved in building construction. There are 95% opportunity that you can save the life of the people just by implementing earthquake resilient practices. That is very, very important. Now, if you'll just see the challenges in earthquake resilience structure is the study of 7,208 damaging earthquakes from 1900 to 2012, around 69.6, that is around 70% of the economic losses we suffered is due to just shaking and vibration of the building. And this is the area, this is the point where earthquake resilient structure, if you are having, I think many structures you can save. And as a person who has worked very down to the earth on the field, civil engineering, site to site execution, around 70% of the collapses or the damages to the structure was due to wrong construction practices. It was not, the issue of structural design or architecture is not the big issue. So only say 10% of that, maybe somewhere. But 70% of the part or 70% of the issues are due to wrong construction practice. And that is what I am going to focus today. because if you just go to the current construction industry, around 60 to 65% of the building construction happens in small individual home builders, where awareness is not there. If you go to big sites, nowadays construction practices improved a lot. That some of the photographs I will use, but there are 65% areas in individual home builder segment where G+2, G+3 buildings are being constructed, and where these earthquake resilient structures are not being executed properly. And some of the examples, ground reality, which is the main my today's topic is ground. If you'll just see this identical buildings before, this is after earthquake, before earthquake the same buildings were same. If you'll just see the observe the arrows, this chhajja as well as this beam, these beams were the same level, but after earthquake this building came down by about 8 feet because of wrong construction practice. And if you'll just see the damage to the column, because most of the building when it collapses, especially in frame structure, it is due to the collapse of the columns, and you can just see the condition of the columns after earthquake. So in this scenario, if earthquake resilience practices are executed properly as per the design, as per the structural design, I think we could have saved those structures. And these are the very famous photographs. Whenever we talk about earthquake resistant structures, we always see this absolutely wrong construction practice, where we cast this portion of most important part of the column, we cast during slab level. And this, if you'll see the color difference in concrete, it will say that this level of the column was casted during column level, but unfortunately the most important part was executed during slab level. So such type of small practices you can just see, and poor quality of concrete and use of poor graded aggregates also plays a very, very important role whenever these earthquake resistant structures are there. And you can just see some very fancy failures. And these are not small columns actually. These are the piers of the bridges and very, very important structures. And one photograph Murthy Saab also showed, this is SWOT columns. People avoid SWOT columns. And these are the most dangerous structures during earthquake, because columns being SWOT, it will not be able to withstand stresses and immediately will fail. So you have to have additional reinforcement, especially whenever we are constructing SWOT columns in the building. That is very, very important. And some of the failures which came down actually due to failure of the column. And the photograph, the second photograph is just very funny photograph actually. Two identical buildings were there, but this building sank. This came down by about 10 feet because of maybe say vibration or the ground on which it was constructed. The capacity of the bearing, its bearing capacity was not proper. And this actually is just the PT situation of the tank. The support was withdrawn. It is just like in political, some parties withdraw the support and the entire structures and entire you can say that come down. But here, fortunately, this tank was there and people immediately took some precautionary measures and it couldn't be saved. And this very famous structure, Mansi complex, where around 48 people died in this collapse. And I, being a local Ahmedabad guy, we visited around 2,000 sites immediately after earthquake. Around 8:45 was the earthquake, and we were in the on the field around 10:30, just helping the people how they can just repair the structures and how we can save the lives of the people. And some very amazing photographs where column failures were there, just because of non-resilient structures, nothing else. And all this Swaminarayan school, where 12 kids actually they were doing experiment in their school, and they were all crushed because of failure of the columns. And these all columns, when studied, no earthquake resilience practices were exercised. No, and drawings were okay. Drawings were not the issue, but real execution at the site is a big issue as of now, even today. And if you'll just talk about the bridges, technically they are very nicely designed, but just on a lighter side, the bridges like this, earthquake-proof bridge, you can just see that whatever the magnitude of earthquake, there will be no damage. And some of the bridges in Meghalaya, they are constructed using roots. It is just on the lighter side. But whenever we are talking about bridges, during earthquake, bridges are also not spared. And this is a Kobe earthquake 1995, huge failure and premature shear failure. You can just see, and the diameter of the reinforcement was very, very less. At the same time, the shear failure also was a big issue. And if you are not going to have pile cap on the, or you can say have proper beams on the column, then you can just see the entire columns came up through the deck slab. That is very, very important. So, but if you are constructing a structure resilient, you can just see there will be no damage. And these are the live examples, right? See, this is the area where only mosque stood and this building, and all the adjacent buildings, they came down, because the main reason is the difference between resiliency and non-resiliency. Here also, no damage to this tower. This small structure came down. Here you can see small individual home builders Here you can just see all the buildings came down. No damage to this. It is ultimately depends how much care we are taking during construction, what precautions we are taking care. And this Ahmedabad, around 350 feet tall tower in Ahmedabad, no damage, and many buildings that were raised down during earthquake. And a tower which was hardly 50 kilometers in Bhuj, no damage to this. It depends on how we construct, how resilient practices we are making. And all this Gujarat Bhuj earthquake, what I have made some analysis on that. Quickly, I will just cover that major reasons were construction on reclaimed soil. Murthy Saab also covered this, that any land you cannot construct, right? We have to have load-bearing capacity testing on that, and then only we can start constructing. Insufficient depth of foundation also was observed. Then it will lead to poor load transfer. Then absence of tie and plinth beam, which is very, very important for transferring of the load during earthquake also. And hollow plinth, Chandan Gosab covered this point, that hollow plinth is technically not allowed. So because even a single column fails, then it will be the question of stability of entire structure. Many of the building I have seen collapsing just due to a failure of few columns, right? That is very, very important. And some more reasons I would like to just, so here is the floating columns. Now they are banned technically. Especially after earthquake, I have not seen, that is a good part. So floating columns are not allowed because it can pose a huge problem. And some odd shape buildings are also were under the question. No, they are still there, but odd shape the building also sometimes during earthquake it may pose issue. And absence of sill level beams, that is very, very important, which is important for stability for this. And poor concrete quality is very, very important. Nowadays, fortunately, due to advancement of this ready mix concrete, the concrete quality has improved, but still in individual home builder segment, this quality of concrete is, yes, there is a scope to improve, which will really help us to improve the earthquake resilience. And if you'll just see the resilience practices, normally what we have seen, which are actually exercised in the field, is the soil testing now has increased. That is a good sign. Depth of foundation as per the report, tie beam and tie beam at the footing level, L column, all these photographs I will just show. Corner beam at sill level and testing of the concrete quality has also improved. That is very, very important. And these are all resilient practice. So if you'll just see the principle, if you want to make your structure earthquake resilient, the rule is the soil must be stronger than the foundation, which you can check as a result of your soil testing. The foundation must be stronger than the columns, and the columns must be stronger than the beams. This is the principle. If you want to make our structure resilient, we have to ensure that these 3 points are there in our structure, which will definitely help us for the strength and durability during earthquake. So here you can just see 2-tier tie beam also. Now people have started good practice. L column at the four peripheral columns, corner columns. Now they have started using as a L columns, which will give better stability in all 4 directions. And some of the you can say lateral ties also. They, as per IS code, also says that you have to band your rings like this. This is very, very important. Even a small mistake, if you are not able to band this, the entire column will get opened up, and it will be a huge problem. And we have seen during Gujarat earthquake, many columns failed because of buckling of this reinforcement. And now, since we are going to have, we are having G+10 and even G+60, 70. So in such frame structures, the shear wall also plays a very, very important role, which is a very, very good resilient practices. And we have seen many of the tall structures, they have started using shear walls like this. On the right side, you can just see very nice concrete, which are embedded in the column itself. So that is very, very important. And the structure which was collapsed, Mansi complex earlier, and now during construction, we have visited this site. Here you can just see all earthquake resilient practices, reinforcement, diameter, concrete grade, and sill level and lintel level beams and were executed. So that was very, very important. And that makes the structure more resilient. That is very, very important. And in load bearing structure, especially in individual home builders, we have started creating awareness for three bands, actually, plinth level, sill level, lintel level. These are very good practices. But unfortunately, individual home builder segment is not much aware, because they are more dominated by masons and contractors, whom we are trying to, earlier also we have conducted more than 2,000 to 3,000 programs just to create awareness on earthquake resilient practices. As on date also, we are creating awareness in our individual home builders activities and all these things. So that will really help us to create awareness. And if you are in zone 4 and 5, the reinforced brick masonry also is now in practice. And one of the important topic of today's webinar was retrofitting. Now see, retrofitting is a very serious activity, right? And it cannot be handled by non-technical people or the people who are not experienced. And some of the examples I will show in Gujarat, after earthquake, within say 24 hours, there were plenty of people who started business of retrofitting. They become expert overnight. And the retrofitting they have done is, you can just see this. This column was damaged. And you can say no concrete was done even for 2 to 3 months. That is very important. And only the part which was damaged, they have just retrofitted. That is absolutely wrong practice. And only up to ground level they were doing. So this also is a bad practice, because I will just show the next slide. It has to be from the foundation itself, right? And without knowing the dimension, without knowing the grade of the concrete and reinforcement diameter, they have just started retrofitting. That is very important. But actual practice is right from foundation. Each and every single column should be executed. Many times we have seen that all the 4 or 5 columns they opened at the same time, which is very dangerous for the stability. But ultimately, we have to, right from pedestal footing, we have to have retrofitting of the structure to the beam bottom or the top of the column. That is very important. And friends, we have seen that concrete quality also has played a very important role, because earlier this volumetric batching was being done. That was very dangerous thing, because nobody knew how much cement, how many aggregates they have added. Only just average 1 to 4 or M20 they were talking about. But now, due to advent of ready-mix industry, I think concrete quality has improved a lot. But still, as I told, individual home builders, small segment still require some of the advancement where they can apply this new technology of ready-mix concrete, and they can save their structures also. And friends, as a person from cement and concrete background, I have observed that ready-mix concrete also, or high-strength concrete also, plays a very important role towards earthquake resilient structure, right? For example, the first point, if you'll just see, improved quality of concrete compared to earlier volumetric, but now it is a wave batching. All the plants, if you'll see the ready-mix concrete or our computer controlled plant, where the quality of concrete is excellent, right? So good quality of concrete will always help in resisting some of the stresses. I don't say it is 100% just by using concrete you can make your structure earthquake, but definitely to great extent it can help. Second part is reduce cross section. If you are using high strength concrete, then definitely you can reduce the cross section, and it also changes reduce cross section. It reduces the inertia forces, which is very important during earthquakes, right? And it also changes balance of beam and column flexural capacity. And these are all topics I have taken from IIT Kanpur. Some of the very good topics they have, one paper they have published actually during how high strength concrete also plays a great role towards earthquake resilience. And satisfies ductility demand. Frames with high strength concrete performs well in satisfying ductility demand due to column and beam size reduction. That is very important. And fourth important point is reduction in displacement and improved shear capacity, which is there due to high strength concrete. And this is due to higher elastic modulus of HSC. It is the modulus of elasticity is higher actually. And slightly lower earthquake loads, because we have reduced the cross section. And due to stronger and beam and column joints, transfer bond and high rotational ductility, it improves. So that also is a good contribution by ready-mix industry. And definitely we would like to highlight more and more towards the engineering forum who can really apply these practices, and we can definitely together can make structures more resilient. And friends, to conclude, I will just share 5 excellent case studies globally. And it is not official, but to me, these are the world's top 5 earthquake resilient structures, right? First is the Sahiba International Airport. Here, if you will just see, it is designed by Owaru, and they have used 300 base isolators. Base isolators are very nicely used in Japan. And now in this structure, they have used 300 base isolators. In Gujarat also, I have seen in Bhuj, many of the hospitals, they have used base isolators, and it can reduce the lateral load by 80%. So vibration on the top superstructure will be reduced by 80% if you are efficiently using this. Okay, and this is one of the largest isolated structure in the world. Second is a Trans-America Pyramid in San Francisco. It swayed by 1 feet during Loma Prieta earthquake, right? And here you can just see the photographs, excellent combination of beams and columns, cross bracings and all. So it will keep your entire structure very intact. That is very important. And up to 45th level, they have used these bracings, which really helped. And if you talk about the world's tallest building, Burj Khalifa, right? Around 0.8 kilometers. It is 8 to 8 meters. And here if you'll just see the walls on the figure in the bottom, all these walls are confined toward the main frame. And during earthquake, all this structure, all this shape will give tremendous stability actually. So that is the earthquake resistant frame they have used as a earthquake resilience structure. And Taipei 101 also was earlier one of the tallest building, but now due to after this Burj Khalifa, it has come to second or third number. And here if you see, they have installed mass dampers, and if you see the weight, 660 tons. Okay, and they are installed between 87th and 91st floor, which helps in reducing building sway by 40%. So due to weight, as well as it will just move in the opposite direction of the sway is reduced by 40%. So that will reduce the stresses in the building to great extent, and it can be saved. And during earthquake, during construction only, there was huge earthquake, but due to this mass damper, there was no damage to the structure. That is very, very important. And the fifth and the last structure is a Filipino Arena, which is constructed by Bureau Happold. And entire structure, actually, if you'll see, again, they have used the base isolators. And base isolators, as I told in the first case, it reduces the stress or the sway or the displacement in the superstructure by around 40%. Okay, so these are the some 5, I thought, case studies which I thought should share with you. And friends, one of the best way of making structures earthquake resistant is please read the earthquake IS code. Fantastic documents where lot many details in. For example, IS 13828 in 1993 revision, they give fantastic criteria and definition. I am sure if you read it and apply as we are doing regularly, will definitely help. And we will be able to make our structures more earthquake resistant. So friends, to conclude, just a last slide. Very nice say by Winston Churchill: we shape our buildings, thereafter they shape us. What quality of buildings, what earthquake resilience we have input in our buildings, definitely it is going to give us shape in the future. That is very, very important. And second part is very important, is when we build, let us think that we build it forever. And if you want to do this, we must implement our earthquake resilience practices, which we discussed today, not only by me, but very eminent speakers who spoke before me. So friends, with this, I would like to conclude my presentation. Thank you very much. And I once again thanks Vicky, NDMA and IDM for giving this opportunity to talk on a very, very important aspect of earthquake resilience structures. Thank you very much.
Thank you so much, Mr. Yogesh. That was a nice presentation. Wonderful things you talked about. One of the major point you raised about wrong construction practices, which is actually a cause of 70% of building collapses. You also talked about short column bane, construction reclaiming, floating columns bane, and you also mentioned top 5 EQRS, that is earthquake resilience structure. And one of the important thing you also mentioned, as well as Dr. CV Murthy also mentioned, that there is a gap between what we study at engineering college and what we actually practice at ground. I guess thereby practicing things at ground, if there is any deviation or gap, it is one of the major reason could be our inability to convince our business management that it is going to save them a cost rather than costing them high. That's a wonderful presentation in favor of saving the time, because we have crossed around 40 minutes more than what we were supposed to do. With my sincere apology for the next session, Chairman. Now I guess it is time for question and answer. So I would request Mr. Rubab, if you could read certain questions posted there, and we can have a bit of time for that.
Thank you.
Mr. Rubab.
Thank you, Mr. Mehta, and thank you all the eminent speakers. It was great listening to you, and something what we were even expecting before this session started. In fact, we are getting some overwhelming response and appreciation across the board from all the participants who are actually watching and witnessing this session. Almost, I think we've crossed the 1,000 figure again for today. The official numbers will come very soon. Quickly, a couple of questions before we go on to the next session, the final session of the day. One interesting question I have, which is relevant to all the speakers. What is the relevance and role of flexible buildings like that in Japan? I think you've spoken about it in presentations also. in earthquake risk mitigation? And do we see the same technologies or similar technologies like used in Japan and Taiwan and other countries? Do they have a scope in country like ours? Are we looking at those options?
So question is to whom, sir?
Murthy Saab, if you'd like to answer, they have mentioned.
Yeah. So I would say displacement is your enemy. And so flexibility is not good for us.
Okay.
But what happens is as you build taller and taller, buildings are naturally flexible. That one you have to accommodate. But you don't deliberately make buildings and structures flexible. If you do that, then the facility that you're housing inside that building or structure is going to oscillate a lot more. So do remember that if you are employed in Delhi and your wife is employed in Bombay, this displacement is not good for you.
Good for you. Okay.
Right?
Wonderful. Yeah.
So I think relative displacement is dangerous, and let us not ask for more relative displacement. Dr. Devasya showed all the false ceilings falling down, right? Not acceptable. Yeah. Displacement, relative displacement, not acceptable per se.
Wonderful. Thank you. Before I take the next question, I see a lot of eminent speakers and personalities joining us. In fact, this question, we have our principal sponsor, Swiss Re, also Amitabha Ray is representing them. The retrofitting which has been talked about, there's a question. Does it increase? So it's a twofold question. Does it increase the value of the property commercially? And does it also help in reducing the premium, insurance premium? So open question. Commercially, how, I know it's a cost, but then does it increase the value of the property after it is retrofitted? And does it also impact the introduction of insurance premium? So 2 parts. Amitabha, would you like to say something about it, or anyone for that matter? Dr. Devasya or anyone, would you like to question that? Answer that question.
Yeah, if nobody's speaking, let me add my thoughts.
Yeah.
First of all, yes, it increases value because you'll be alive after the earthquake. So that is the first value I will give to, in the country where we talk of money and we talk of materialism, I'm wanting to talk about human life. I think if you start giving value to human life, then the premium of the building or structure will go up. That is the first one. If you do retrofitting and your business is continuing, yes, you have value. There is no doubt about it. So I think the question for me is a non-question, because you have to give value to your own self, your own existence, and then to the activities that you're doing for the good of others. So that's why I ask always for a noble cause. If the cause is noble, retrofitting is genuine.
Genuine, absolutely. And these words are always echoing whenever I discuss this thing with you, Dr. Murthy. It's what is bigger? You very precisely said what is more valuable, human life or money?
Yeah.
Because what is bigger and more? What is the priority? I mean, money will follow. I mean, if you're alive, you can enjoy the money, as you told
and
me
we
last
can convince insurance companies to give us a lower premium, annual premium, if our structure is already retrofitted or it's at a higher level of earthquake safety. We can negotiate that. We can set up the agreements with those companies also.
Yeah, I want to just one thing to add to this is that majority of the building types and the kind of failure that our building, even Mr. Barrett also has shown, the buildings that when we select out of maybe say 1,000, maybe even one building also we select, we have to go for it is something like a surgical operation or brain or some tumor operations in the brain. So in that case, doctors also has to go through certain procedure, CT scan, anesthesia, and all these things. But the kind of buildings that we have been constructing, barring few, majority of the building having so much defect, which you can see from the construction itself, whether it is 30 years, 40 years before, all kinds of construction. And I have shown few examples also where corner is showing, but column-like color is also there. So assessing the precondition before or evaluating that to fit it operable through a retrofitting jadoo is a really challenging, and majority of the building, they fail this test. Means they cannot be given anesthesia just before operation. So that becomes a more challenging then, you know, retrofitting the technology that which has proved over in several countries that proved that its efficacy and functionality.
Thank you. Thank you. So I think we have a list of more questions which we can compile all of those in, you know, and send it to the speakers whom it is directed towards, and we'll expect an answer for those questions so that, you know, we can you know, ensure that answers reach out to the people who've questioned those. Moving on now, we are on the final session. We are much behind schedule, but thank you so much, all the speakers from session 1. This was a great privilege and honor to listen to all of your thoughts. Thank you so much, Chairman Rituraj Mehta ji.
Thank you. Thank you.
And before we end this first session, the third session and first session of the day, Dr. Murthy, I promised you that, you know, we'll have an industry interaction where we will talk about this retrofitting, and I think I hope part of that promise has been fulfilled, and we will make sure that, you know, we take it forward. You, Dr. Ghosh, all of us together. We have Rituraj ji and people from the industry. Yogesh ji is here, and Dr. Devasya. We will definitely take it forward. What you have advised in your presentation.
We can meet sometime next week again to follow up on this and
definitely.
Subject.
Absolutely. Thank you so much. Thank you. Thank you.
Thank you. Thank you all. Thank you so much.
I would like to welcome, before I start the second session, Dr. V.K. Sharma. Professor Saab, thank you so much for joining us, sir. Professor Sharma is with us, Vinod Kumar Sharma ji. I would request now the next session, which is on use of technology, geospatial data, remote sensing and early warning systems for earthquake preparedness and response. We have a list of, again, eminent speakers. We have chairman of the session, Dr. B.K. Bansal, who heads the National Center of Seismology, Government of India. We have Dr. Sushil Gupta, disaster risk management expert and AVP, risk modeling and insurance, RMSI. He will be talking about application of Indian subcontinent earthquake risk model on infrastructure vulnerability and risk assessment. We have Dr. Anil Gupta ji, professor and head ECDRM, NIDM, Government of India. Thank you so much, Dr. Gupta, for being with us and all your support. Dr. G. Suresh, scientist G, from National Center of Seismology, Ministry of Earth Sciences. Thank you so much, Dr. Suresh, for joining us. He will be talking about use of spatial technologies in earthquake management. And the last but not the least, one of the most important presentations of our two-day conclave, Dr. Mahua Mukherjee, Professor and Head Center of Excellence in Disaster Mitigation and Management, IIT Roorkee, UNDRR APSTAC board member. She will be talking on industrial ecology based resilience planning. So on that note, without taking much time, I would request the Honorable Chairman, Dr. P.K. Bansal ji, to please take it on from here.
We need to play that video for our minute.
Yes, so there's a 60-second video, BK ji, and the moment we do finish that video, I'll come back to you. Thank you, okay. Thanks for reminding. Thank you, RMSI, for being our associate sponsor. Thank you so much. Over to you, Dr. Bansal, please. Thank you.
Thank you, Dr. Sood. And I welcome all my speakers in this session, 4 of them. And I will just say on the joking side that the previous speaker or previous session, they could afford the 45-minute delay. And of course, I don't mind if you carry on, it's fine, but the lunch will be, waiting in between you and your presentations. So all of them, the 4 speakers, Dr. Sushil Gupta, Professor Anil Gupta, then my colleague Dr. G. Suresh and Professor Mahua Mukherjee. I think I know personally to all of them for quite some time, and it's a really pleasure to see them here to make this presentation on a very appropriate occasion when the FICCI is organizing this wonderful webinar. So without delaying any further proceeding, I would request all my speakers, first Dr. Sushil Gupta, to give his presentation, but still I will request that please maintain the timings. It would be always good to have some kind of discussion, maybe 5 minutes after the presentation, because some people definitely want to discuss a little bit. So Dr. Sushil Gupta, over to you.
Thank you, Dr. Bansal. I'm sharing my screen. So my screen is visible?
Yes.
Yes, it is.
Yeah, thank you. So topic of my talk is the application of Indian subcontinent earthquake risk model on infrastructure vulnerability and risk assessment. We have developed this earthquake model for Indian subcontinent, which is covering India, Pakistan, Nepal, Bhutan, Bangladesh, and Sri Lanka. And this was released in, first version was released in 2015. And then every 6 months we are revising it. It contains earthquake events, more than 25,000 from 1718 AD to August 2020, including Nepal earthquake of April 2015. And I would like to explain a little bit on stochastic event set. So our catalog has a stochastic event set of more than 90,000 plus event. So this is basically, when I say stochastic event, we have taken all possible scenarios into consideration and then developed this model. So I put almost 28 years of experience, my experience on this since I was working in Department of Atomic Energy. Here we have used NGA, latest ground motion attenuation relations, GMPs, including we have done the local soil amplifications. I will be explaining this. And this model has been validated and calibrated on following earthquakes: Balochistan earthquake, Hindu Kush, 2005 Kashmir, Bhuj earthquake, Nepal Bia, Chamoli earthquake, Latur and Uttarkasi earthquake, etc. This is basically a model framework for the hazard assessment. So where we have like earthquake catalog first that need cleaning and different steps. So these are all listed here. I will be sharing copy of my presentation, and then local soil amplification as well as liquefaction potential and landslides. They are covered in a way into the vulnerability modules. These are the sources of our earthquake catalog, which are more than 20,000 plus. So we have taken even a lot of research publications into considerations. When I say composite earthquake catalog and seismotectonics, we have taken all seismotectonic features in and around, not only in India, but surrounding India. So because we have developed a model for the Indian subcontinents. If you see some part in and around India, so in Nepal, sorry. So if you see India and Nepal, so we have covered so big area, and you can see the structures there, geological structures. This is on Pakistan side. These are the events which has happened between 2005 and 2015. So just to give you like statics, how numbers are like increasing. When I say seismic source zone modeling, so we have modeled almost 340 seismic source zones and calculated seismic parameters for each seismic source zone. So of course, background seismicity is also there. So these are the source zone in and around Nepal. So just to give a glimpse on Pakistan side. In total, there are about 8,400 line sources, and minimum magnitude which we are considering, like for Peninsular India, is 4 to magnitude 4 and above, but for rest of the area, which is apart from Peninsula, it is 5 and above. And our MX maximum potential of each seismic source zone, it is ranging from 6 to 9.25. As you know, this is how building respond. So I would like to say it is a concept of response spectrum, and all of us might have heard about concept of resonance. So if earthquake ground motion, which is on the, like say on the bottom, if earthquake ground motion has a number of frequencies, And similar is the case of our structures. They also have their natural periods or natural frequencies. So if a building natural period matches or nearly matches with a say earthquake ground motion, so then it becomes the concept of resonance. And you can see if a structure is there between say around 0. With a natural period of 0.5 second, so that is structure of 0.5 second means it's a 2-story structure, then it will have maximum response. That means it will have the maximum shaking. It will experience the maximum ground motion. So this is more on the then estimation. As I already said, we have used following attenuation relations. We have also estimated the local soil amplification using VS30. And then we developed the hazard map. I will touch upon on soil amplifications also, how we improved it. This is more on geotechnical hazards, that soil, as you know, it modifies the ground motion intensity. Liquefaction and landslide we have covered into the vulnerability modules because they increase the damage ratios. So site amplifications, there are now VS30 values. Even there is an approach from USGS, which is called by Walden approach, in which you can directly get the VS30 values from the slope through the slope studies. But these values, as we studied and we found, they are not perfectly in match with the observed values or values measured through instrumentation. And here is example from the Gujarat, one example. So we wherever we could get these values, VS30 values, observed values, or through indirect methods. So we use those for this validation and calibration of our VS30 values. And this is a one simple example of validation of Gujarat earthquake. So you can see all these points we have intensity values. And this is a MMI footprint, which we converted from ground motion to MMI. And this is a kind of a validation of the model. And then we have even shown in the tabular how intensity observed and what was the estimated intensity and how much is the deviation. So to be on conservative side, we try to keep the variation in positive, and you can see hardly about 20% is the maximum, which is the variation. Because if you know the observed intensity, they are in complete numbers, they don't have a decimal value. So that may be another reason of these uncertainties. These are the return period maps which we developed for the hazard, and these values on the hazard, they are actually the mean values, mean or median values. So they are not the values which you see in the actual ground motion PG values. So please don't get confused with that. So this is for 1,000 years, 250 years. And then next, which is a bigger task on this is the exposure module. When we say exposure, exposure is all the humans and the building and infrastructure. So we have taken in our model this, all the buildings which are residential, commercial, industrial, infrastructure, all kind of critical infrastructure, as well as all the road network, rail network as well, then transportation network and utilities, including agriculture. So why this model need to be updated every 6 months? As you know that exposure is dynamic. Our exposure is changing. I'm just giving example from typical from Yamuna riverbed. This was the situation in Yamuna riverbed in 2001. But if you see in 2010, a lot of construction has come. And if I see now 2020, it will be much more changed. So to elaborate more on exposure, we have done a sub-pin code level resolution building cluster data. And this has been extracted from high resolution land use land classes data. And 51 urban agglomeration of India that is developed in very detail, and which also include industrial and commercial corridors in the country. And then we have even classified our these clusters, building clusters with occupancy as well as with height, because you know height is also important as well as the occupancy. Height from the perspective of the natural periods or natural frequencies. Then the assessment has been done at pin code level as well as by aggregating on the basis of occupancy and height informations. And we have structural vulnerability functions of 29 different classes using the combinations of wall material and roof materials. And this population we have projected to 2019 from the census 2011. On vulnerability, I said we have developed a damage function for human vulnerability, structural vulnerability, content vulnerability, and function vulnerability. On structure side, even on building, we have 29 classes. This is just an approach how we like vulnerability functions are developed. So to save on time, I will not be explaining much. So figure is very well. Means if you can see on the top left corner, there are on the y-axis there are damage ratios, on the x-axis there are the spectral accelerations, and the best fit line that represent this damage, it is called damage ratios. So damage ratios typically varies from 0 to 1. 1 means 100% damage and 0 means no damage. This is a typical example how these damage functions look like. So as I said, we have developed 29 vulnerability functions based on structural type, height of the building, roof and wall material, and covering all three classes of buildings: residential, commercial, industrial. And these damage functions are derived using the learning from these earthquakes. Uncertainties, it is very important in earthquake. As you know, earthquake has a lot of uncertainties. So we have taken into consideration uncertainty at hazard level, at exposure level, as well as in vulnerabilities. So uncertainty is important aspect in earthquake, as we know that even at the same location, same magnitude earthquake happens again, it will not produce the same ground motion. On financial module side, we have like, these are the typical outputs. When you say loss analysis, we estimate average annual loss, we estimate loss cost, we estimate EP curves, accidents probability curves. EP can also be defined as aggregate EP or occurrence EP, accidents probabilities, probable maximum losses. And then we also generate loss analysis report and what are the key drivers. Risk drivers are also important. So we give input, what are the key drivers if we are like analyzing a portfolio of buildings or infrastructure. So in conclusion, I would say this RMSI Indian subcontinent earthquake model allows hazard and risk to be quantified. Risk need to be measured both temporally and spatially, and this is where that geospatial technologies come into picture, both GIS and remote sensing. Risk is increasing as exposure is increasing, and our exposure is increasing in more vulnerable areas. Even previous section, it has been explained a lot that we cannot use every piece of land for constructing buildings and infrastructures. Now we are seeing a great reliance on CAT models to assess the frequency and range of the future risk outcomes. And if you intelligently used CAT models, catastrophic models help in identifying risk drivers, thus improving decisions. These models, they are already in use for analyzing portfolio losses, for insurance reinsurance industry, as well as for earthquake disaster management perspective in the subcontinent. Thank you. I hope I'm in time.
Thank you, Sushil. It has been really very crisp and clear presentation, I must say. And where the first session left, I think you are feeding them for for designing the structure. Basically, earthquake hazard is the need of the day. If you have the accurate assessment of seismic hazard, probably we can do much better, because all of us are aware that prediction technologies, they are not in existence anywhere as of now. But at least if we are able to really accurately assess the current hazard levels and put into that levels into our design, probably things can go in a much better way. We can reduce a lot of damage due to future, calamities, etc. So thank you, Dr. Sushil Gupta. So
thank you, Chairman.
Can I take the next presentation now from Professor Anil Gupta, NIDM?
Thank you, Chair. And thank you to FICCI and all the collaborators for this initiative, Mr. Ruab and his team. Am I audible, Ruab ji?
Yes, sir, you are.
Yes.
Yeah, thank you. So I was listening to the excellent presentations yesterday also and today also. And very important deliberation took place. And this panel is also discussing very important themes. So I have brought in here to discuss certain things related with the planning and management issues that for particularly for the infrastructure resilience in developing countries context. So I am sharing my yes, PowerPoint.
So as you share your PowerPoint, sir, I would like to welcome Dr. Muzaffar Ahmed, the former member, National Disaster Management Authority. Welcome, Dr. Ahmed. Thank you so much for joining us.
Is my PowerPoint visible?
Yeah,
Yes,
yeah,
sir.
please.
Yeah, thank you. Okay. So there are a kind of a multiple challenges when we talk of infrastructure, and there are also engineering issues, but beside this there are a lot of non-engineering issues also, and therefore in fact we required an integrated approach when we talk of infrastructure resilience. So while we are looking at the technological solutions for improving design, material, and also the ability to understand the stability context, there are also equally important issues of governance, participation, and the effective planning and monitoring. So these kind of things. And if we look at the background that I would like to refer here, that when we say infrastructure resilience, then it goes beyond structure. So that is a very important thing. And we also need to have a clear understanding what really we want to emphasize when we say infrastructure resilience. And then there are a couple of other conceptual issues. For example, when we say critical infrastructure, then again, if we start counting critical infrastructure, then the criticality is also so blurred that maybe sometimes we say that hospital is a critical infrastructure, then the communication system is a critical infrastructure, then transport related things are critical infrastructure. But even schools and colleges, because those have dual services as a basic service, but also it serves as infrastructure, safe infrastructure for relief and keeping the people when they are evacuated, particularly in cyclone and these kind of things. So there are several dimensions to understanding of the critical infrastructure and broadly the infrastructure resilience. And currently, as we are working with the NDMA and NIDM, we are trying to mobilize all the ministries of Government of India, and also down the line, all the ministries and departments of the state governments also to prepare their disaster management plan. Basically, the purpose is to mobilize the sectoral planning process to integrate the concept of disaster risk management. And that is related with the Prime Minister's 10-point agenda on disaster risk management. The item 1, that is on all sectors to imbibe the principles of disaster risk management. And there, in fact, the principle that is called the CUSP principle. So CUSP is culture of safety and prevention. Their infrastructure appears to be one of the central point, that the infrastructure should not be such that it aggravates the hazard and vulnerability, but on the other hand, the infrastructure should be such that it helps reduce the vulnerability and hazards. And third, the infrastructure should be such that in case of disasters, the sector is able to, and in a state of preparedness, to respond to disasters. So there are 3 dimensions which are associated with sectoral infrastructures, and all the sectors have some or other kind of infrastructure, but it varies from sector to sector. For example, if we talk of the petrochemical sector or other kind of industry sector or agriculture sector, then food processing sector, then certainly there are common infrastructure, but there are differential infrastructure also. But I would also like to point out here, since this conference is focusing on earthquake, but when we talk of infrastructure resilience, then we have to go multi-hazard. if we think of building a housing complex or an industrial unit only resilient to one particular disaster like an earthquake, or in coastal areas, if we think of only resilience only to one hazard like cyclone, so that would not give the complete story of the resilience, because we have to also draw the lessons from the past complex emergencies. Like Fukushima is one of the major example before us. That started from earthquake, then converted to tsunami, then the flooding, and then led to a chemical, then a nuclear mishap. So how one disaster can be a trigger factor to another disaster. So we cannot leave aside this understanding which has emerged recently before us. And during the past cyclones also, particularly both the super cyclones 1999 and the recent one, China earthquake also, Bhuj earthquake also, we saw that there has been a lot of secondary that triggered a lot of secondary disasters also. And then the issues which are of consideration for us when we work for kind of a policy planning approach for infrastructure resilience, then this picture shows the kind of pressure on the infrastructure that is in our cities and development. So the inadequacy of infrastructure, and this is actually holding this developmental process. And then on the other hand, if we look at our journey to achieving the sustainable development goal, that is 2030. So in fact, not only 3, although I have mentioned here 6, 7, and 8, but in fact, more than 10 of these 17 goals are associated with the infrastructure. So when we say infrastructure, then it also talks of resilience. For example, currently we are working with one of the IITs in understanding the requirement of resilience of the solar power plants, because the solar power plant may be located in earthquake-prone areas, they may be located in high wind areas, may be located in the coastal areas, may be located in like Rajasthan, with that is the heavy sand storms and wind storms are there. So that can affect the structural stability as well as the functionality. So how these things are important for achieving SDGs. Then this is also a fact, and we all have realized that the world is moving. World is very fast urbanizing. So rural areas are converting to, then there are some examples of like rural-urban systems are then the urban areas expanding, engulfing more rural areas, then peri-urban areas, and maybe after a few years, 6, 7, 10 years, we have to expand the boundaries of our cities. And this is also a reality that even as on today also, that the urban areas are how the 50% of the population is some or other way it is urban. And if we look at the kind of the projections, then more than 881 billion to 6 trillion US dollars. That is the projected range of investment in the infrastructure by the year 2030. And it is also predicted that millions of people and the huge losses of more than 4 trillion US dollars only by the climate related disasters. But yes, climate related disasters account for almost 60 to 70% of the disasters. So there is a lot of complexity. But I would also like to refer here that Uttarakhand in India faced a major catastrophic disaster in 2013. But usually what happens in our damage assessment, we assign the entire damage to one particular disaster. So we think that entire damage that has taken place in Uttarakhand in 2013 is because of the flooding that year, which may not be absolute, because there are certain percentage which is the kind of a which has been set the stage by the previous disasters like earthquakes and the previous floodings kind of things also, because that makes your infrastructure vulnerable to the future disaster. So that is also the kind of thing that how one disaster makes the system vulnerable to damage by other disasters. So maybe the first earthquake has come and then it has damaged some buildings, but it has shaken some buildings, but not fully damaged. When then other disaster comes and makes it totally collapsed. So these kind of things are there. So what is the kind of a scope when we think of a policy planning regime for infrastructure resilience? So one is that how do we explain infrastructure resilience? Because if we look at the smart city programs, we have been struggling for past 10 years or so, and before that the JNU RM, that how the resilience factor and resilience aspects are integrated into this concept. But there has not been very significant success. But yes, now we are trying hard, and there are some windows which are appearing to us, and that effort is on. Then the infrastructure looking into urban context, our infrastructure looking into the industrial and rural context also. So within rural areas also now infrastructure is growing very fast. Now, in fact, if we look at that, the infrastructure development in our northeast areas is very fast. So then there can be some kind of a subsets of understanding infrastructure resilience requirement, because there may be different factors in hilly areas, there may be different factors in coastal areas, there may be different factors in high heat areas. For example, Andhra and Telangana, these states are facing high heat. So industrial infrastructures need to, and even the urban infrastructure need to integrate the requirement of the resilience against the high heat conditions. That is also required. So new issues are emerging, and therefore we say that the infrastructure resilience is not about the structure, but overall the functionality, that keeping the system functional. That is the actual requirement, and that relates with the amenities, services, goods, this entire range of things. Then there are also two important lessons. One is intersectoral dependence. For example, the water supply system heavily depends on the power supply system, and even also now when this is the time of automation and the digital governance. So on communication systems and these kind of things also. Hospitals will depend on the transport, because even if the hospital is intact, but if the patients cannot reach to hospital or the doctors cannot reach to the patient, and if the inventory is poor, and then the hospital the supply of medicines is disrupted, our supply chain is disrupted, so things cannot work. So the dependent interdependence of the sectors. Then within the system also, within for example, if there's if we look at the tourism sector, and there is a hotel complex or a resort, or on the other hand, if we look at the hospital, so within the healthcare facility, there are subsets. So resilience cannot pertain only to building, but we have to look beyond. Otherwise, sometimes what happens that the building is building design and building is stable, but there are a lot of fixtures and other things which are not taken care, and then lot of tragedies and lot of damages are taking place. So those things are important, and keeping the system functional, that is I think is equally important. Then and therefore infrastructure to be resilient in terms of design, finance, regulations, standards, policy, and then finally mainstreaming into the overall planning process. So the departmental planning, how we integrate the resilience into the departmental planning process. Then I would like to give the example of the education sector, that how we integrate the safe school concept, safe school for all kind of disasters, integrate into the overall the departmental planning, and for development of these infrastructures. So it will start from location to material, design, budget, everything. Then it is also important that we have a good compendium or good collection of good practices. And here in fact I have written best practices, but I would also say that we can go even beyond, and we can even document the failure practices also, or the failure stories also. So this is important. And in fact, for a resilient infrastructure governance, it will require three important pillars. to work upon, that is the system, institutions, and actors. So systems maybe the engineered systems or the natural systems. One of the speaker co-panelists here, Dr. Mahua, would be touching upon the industrial ecology and the nature-based solutions also. So that natural infrastructure is also important. Then institutions, for example, the urban local body within rural areas, with the PRIs, or the district administration, or the district disaster management authority. So these institutions, how the institutions capacity and how the institutions have incorporated the lessons and understanding of the resilient infrastructure, that is important. Then actors, sometimes systems are perfect, but we are not able to get the desired result. So actors, for example, if we talk of the housing sector, then actors are like the person who owns a home, or who is going to construct his own house, or the builder, or the agency which is constructing a house. And then the kind of engineers, planners, architects, masons. So how we are looking at the competencies of these actors, are the attitude building of these actors for developing resilience. So these are the important dimensions within this. Then it is also important that the urban infrastructure is often the kind of a common focus, and although the bridges and these kind of things also are being discussed, but rural infrastructure, though the size of these infrastructure units may be smaller, but need to be given equal emphasis, because that will also help us reduce the rate of migration from rural areas to urban areas, and maybe it can help ease the growing pressure on our urban systems and expanding pressure on the peri-urban areas. So this is also important. Then industrial systems, like industries, are also prone to earthquakes and these kind of disasters, and in the past we have seen that how they suffer. But industrial disaster management plan has not been operationalized. And I have been talking about these, that the industry should also start planning not only about the industrial accidents or the safety issues, but industrial safety need to incorporate natural hazards as well, and therefore it requires a multi-hazard disaster management plan. So that is an important lesson that has recently come up. And then it is also important when we say the climate change is exerting pressure. So when I say climate change is exerting pressure, but vulnerability does not fall from sky. Maybe the heavy rainfall, wind, all these can be the natural factors affected by aggravated by the climate change. So equal emphasis and weightage is required to non-climatic actors. So this is very important, that how the anthropogenic contributions, how land use flaws, how the poor implementation of the building bylaws and regulations, those are important. Then we also need to look at that where are the gaps in availability of the building bylaws. For example, the flood resilience buildings, wind resilient buildings, these kind of things, and how the heat resilient buildings, how we are going to integrate these things, and integrated building codes region wise can be thought of. Then addressing impact of disasters, this has already been discussed, but the infrastructure resilience, hence based on this experience, then logical layers are emerging, and there we have to look at, for example, if we say that the resilient infrastructure in the state of Andhra Pradesh, so what are the different layers? For example, heat will be one layer, earthquake may be a layer, and if we move to a coastal state like Kerala, so what will be the layers there? Actually, then the broad framework of building resilience or structural resilience has to be drawn. And there, in fact, the requirement of also giving equal focus on non-engineering actors, like I discussed about the non-climatic actors. So here I would say that non-engineering actors, like sometimes people have very good knowledge, people have the technical competencies, but that doesn't transform into implementation. So those operability kind of things, that is also important, that whether that is a lack of incentives, that is a lack of motivation, or a kind of a window of corruption, or so what are these things? So this picture also shows that the requirement of infrastructure resilience in terms of the functional sustainability, that it keeps functioning. Then the infrastructure doesn't, the building of that infrastructure doesn't aggravate risk building or even the operational of that infrastructure. And then this interdependence that I discussed in the previous slide. Now, there are additional contexts which we also need to take care when we discuss about earthquake and multi-hazard resilience in our infrastructure system. So how we look at, because many times I gone through various vulnerability analysis scoring parameters, for example, under this smart city program or ACCRN or 100 cities, and even supported by CDKN. I have been associated with some of the projects, but many times I found that this has been a kind of a critical observation, that the set of vulnerability parameters, there has been so much of complexity, and then how we are assigning values and how we are assigning kind of a different ratings. So entirely different kind of understanding. So what can be a common module for vulnerability, infrastructure vulnerability understanding and building resilience? And there actually that can then we have some good pilots, so that can be emerge as a kind of a implementation examples. Although in our country also we have some good examples, but if we look at the kind of the ground results, we still need to fine tune a lot. Now India emerged as a leader in CDRI, the Coalition for Disaster Resilience Infrastructure. So that is a good opportunity before us to work towards multi-hazard infrastructure resilience. Then how to integrate the infrastructure resilience issues into our district disaster management plans. Now currently on the directive of the Green Tribunal, all the districts have been asked to prepare environmental action plans. So how we look at the convergence between the district level development plans, district level disaster management plan, district level environmental action plans, because the environmental action plans would also deal with a lot of environmental services, including the waste management, water supply system, and certain other things which may be related with heat, flood, these kind, and also waste management, disaster waste management. So these things will come. Then the ULBs, these are also the units which are important, that how we integrate into the urban master plans and the urban and the city plans. And can we also think it taking it down to rural development plans or the panchayat level planning process, because that is in fact equally important. Then coming to certain more issues.
Professor Gupta, sorry to disturb you in between, but I think it would be nice if you can sum up, please, now.
Yeah, I think this is my last slide. So I will be now would say that the urban infrastructure resilience also requires to integrate the valuing natural infrastructure. And we have very good lessons from some countries. For example, Chicago is a very good example that how the greening of infrastructure has contributed to resilience against various hazards. And but we need to customize to the regional and local requirements. We cannot just copy these kind of models. And then the resilience in infrastructure should also take care of the social context, like livelihood, poor children, because sometimes the very good infrastructure within the heart of the city, but a very poor infrastructure in the peri-urban areas leads to the aggravated challenges for the urban poor children particularly, and the women. So these kind of things are there. And I would like to skip here because some of the issues are already covered here. But I think that a holistic model of infrastructure resilience, looking into all kind of disasters, that is important. So thank you very much for giving me this opportunity to share some of my thoughts. Thank you very much. And I have mentioned here my ResearchGate address. So the outcomes of my pilot projects where I have contributed to the infrastructure dimensions are available. And if colleagues would like to refer to these. Thank you.
Thank you, Professor Gupta. In fact, it has been a very interesting, topic, and the lecture or details, whatever you have provided, they are really tremendous. The management perspective is really equally important. Whatever science we are doing, how we convert into that science into management plan. So that is really a very good aspect. And Professor Gupta has given, so many examples, whether they load on our infrastructure, engineering actors, non-engineering actors, because in general, many things are not known to every one of us. So this is really fantastic, and had the time permitted, we would have really kept on enjoying this listening to you. But moreover, I think we can have sometime in future also some good interaction with you. So thank you very much for really giving such a thoughtful presentation. And I'm very sure the other speaker and other participant will definitely get benefited of this important topic. Thank you, Professor Gupta, once again. So may I call upon the next speaker, Dr. Suresh, please? You are mute, Suresh.
I will share my screen. Okay. Are you able to see my screen, sir?
Not yet.
No?
Not yet.
Not yet, Dr. Suresh. We will send you the right. Yeah, now it's visible.
Yeah. Yes, okay. So I'm going to talk about the this is a geospatial use of the geospatial technologies in earthquake monitoring. And see the left side slide shows that Indian subcontinent covering an area of 3 million square kilometers is drifting in varied and complex manner with 3 to 5 centimeters per year in north-north direction, colliding with the Eurasian plate, and which is we know that which is comprising of the Tibetan plate and Central Asia. So the right side slide shows that this is the seismicity pattern from the last two centuries. So we can see that the seismicity is mainly concentrated in the Himalayan collision zone and this northeast part of India, where the juxtaposing of the east-west trending Himalaya and the north-south trending Arakono-Yoma belt, which is contributing to these earthquakes in the northeast part of the country. And also this is a subduction zone. We know the Andaman Nicobar Islands, and this active intra activity in Gujarat part of the western part of the country. So this is the we use the spatial technologies in our earthquake monitoring, and spatial information related technologies we use it very for the operational activities of the earthquake monitoring. So in this thing, one of the challenges in earthquake monitoring is to provide reliable and accurate and timely spatial earthquake information soon after the earthquake occurrence. So for this purpose, we are doing the round-the-clock earthquake monitoring through earthquake monitoring to quickly estimate the source parameters soon after the earthquake occurrence and disseminate the information to the all this concerned state and the central government agencies. And for carrying out the relief and rehabilitation measures. So we use the GIS value-added products coupled with the decision support system for publishing the information on website and social media. I will come to that part later on. So this is the data we are receiving from the 115 seismological observatories. All these seismological observatories equipped with the broadband sensor and accelerometers. Data is coming on real time through by VSAT connectivity, and there is a algorithm which is working for each station to monitor the signal to noise ratio. So once the signal to noise ratio exceeds at the at the 4 or 5 stations, then it determines the automatically it determines the earthquake parameters, and then these earthquake parameters will go into our website, mobile app, and other social media. So this is the first. Since the data is keep on coming in real time, and this earthquake parameters is get modified as the data keeps on coming. So once an earthquake happens, and depending upon this earthquake magnitude, and then we determine the focal mechanism, how the faulting has taken place, and what is the expected intensity at the different parts of the in the epicentral zone close to the epicenter. So earlier, now we are using the analog observation. That time we are taking about 1 hour for dissemination of earthquake information. Now digital observations were started in 1997, and that time we are using the dial-up facility, telephone dial-up facility. That time we are taking about 30 minutes for determining the epicenters. And now then we introduced the auto location softwares, which continuously fetch the data from the data acquisition system spread across the country, and then process the data in real time, and then it is reduced to the 10 minutes. So by adding more stations, later on in 2018, we increased the strength of the our national seismological network, and then we decreased the dissemination time to 5 to 8 minutes. So this is the since because this is limited by because the waves has to travel here, and it has to be recorded by the 5 to 6 station, and then first cut will come, and then as the data keeps on coming, the parameters get revised, and once it get, always we should note that the parameters determined by the auto location software is not always correct. It may be false also. Then the duty officer there will revise the parameters and publish the information to the website. So we disseminate the information in 2 levels. One is called level 1, and another one is a level 2. So soon after the earthquakes, for example, the earthquake recorded by at least 5 or 6 stations, then the epicentral parameters, earthquake parameters were determined, and this earthquake parameters immediately will get published in the website and mobile app, and it will be disseminated through by SMS to the within the MOES and NCS core officials. So always this is done with the by the auto location this program, and then some following some algorithms, and so it may not be right all the time. The duty officer will revise the earthquake parameters and do the analysis, and then revise the parameters, and these revised parameters will be disseminated to the all the decision making authorities, Ministry of Home Affairs, central state government agencies, media, public, and through by SMS, and then email, fax, website updation, Facebook, Twitter, and mobile app. So this is our dissemination part I am seeing. For this, we are using different GIS platforms, GIS techniques, and this is the first one. This is the website. So soon after the earthquake occurrence, once the wave is recorded at 3 to 4, 5 to 6 stations, that will happen within 2 to 3 minutes, and then that parameters get published in the website, and then it is again reviewed, and after the review, and then it is again the earlier parameters was replaced, and then and displayed again, and we can see that this is a website of the this is 24/7. It keeps on updating after the earthquakes, and also we disseminate the information through by mobile app. So that is the mobile app is known as the RISE-Q, real-time information system for earthquake, and this can be downloaded through by our Google Play Store and the app this iOS app store, and we can I request all the participating members to use this mobile app for getting the information of the earthquake parameters. So, and also we publish the earthquake information on the Facebook, and we tag it to the NDMA, and also with Twitter. Both the informations are tagged to the national agencies, NDMA, and state government departments, and also we publish the information through by WhatsApp group also. This is the WhatsApp group. We disseminate the information to all the decision-making authorities. So next is the we also NCS also does the seismic hazard microzonation. So we know that India is divided into the 4 zones, seismic zones, and this seismic zones a distribution of earthquake in a particular zone has a wide variations in the intensity of ground motion and spectral acceleration due to change in geology and geophysical, seismology, and geotechnical properties. So we divide the area into smaller units with the uniform hazard level and nature. This classification is done based on the geoscientific, geotechnical, geoseismological, and engineering seismological parameters. So here you can see that. So here this is the bedrock. This is the input waveform input motion due to the earthquake for the different layers is same. So here this is the bedrock. This is the bedrock, and this is the very number of layers are very small. This is the density, shear wave velocity, and impedance contrast. So when the structure is very close to the bedrock and based on and constructed on the hard rock site, then it is you see that there is not much change in the ground motion observed on the surface and the bedrock level. So so that time this has rich in higher frequencies and can affect the single story buildings or very short story buildings. And next we can see that there is a number of layers have been increased to then the period will increase. Then you can see that then it will be affected by the 2-story building, 3-story buildings, and medium story buildings due to that ground motion. And once the alluvium soil thickness will increase, the number of layers also will increase, and then the ground motion, then the period of the vibrations also will increase, and then you can see that there is a increase in the period of the ground motion, and then it will affect the multi-story buildings. So we can see this slide will explain how the earthquake will affect the soil condition, the structures on the different soil conditions. So we performed this NCS National Center for Seismology has completed the seismic microzoning of Delhi and Delhi region. I will come to that later on. And how it was done. First, we do the source characterization. We find what are the sources of the earthquakes, different faults within the 300 or 400 kilometers of the from the region, and then a ground characterization. We study the subsurface properties of the region, and then it will go as and it will analyze it through by a software or through, and then it will go into the hazard parameters and generation of different thematic maps. So the peak ground acceleration and amplification factor, engineering bedrock, and then liquefaction potential and the shear wave velocity and the spectral acceleration, etc. All those things we use the spatial technologies widely for this generation of the very thematic maps in preparing the microzonation of a particular area. So here we can see that peak ground acceleration due to the design-based earthquake, and then at the and the maximum credible earthquake. So this is the different PZA has been prepared from the input from the subsurface measurements, and then amplification factor is determined from the Nakamura technique. As by we from there also we prepare how the peak frequency and the predominant frequency is varying at different sites. So the lesser the predominant frequency, that means the more the period, means it will affect the buildings with the high-rise buildings, and if the predominancy frequency is high, means then it will affect the low-rise buildings. So this is another is the shear wave velocity, and shear wave velocity will tell about the different layers, and we say that it is VS30 will give the engineering bedrock of the area, and these maps have been prepared, and then liquefaction potential by conducting different studies, and then so we know that. So number of stories of the building, say if you say n, and then what is the typical natural frequency of the structure divided by 10 divided by the number of structures. So number of stories, and then if it is the number of stories is 2 and the typical frequency is 5, and this is the number of stories 50, means it is a 0.2 second hertz, means it is a 10-second period approximately. So all this the thematic maps have been prepared using the GIS technique, and then they have this is then weighted average integration of multiple techniques have been used to combine to generate into the one hazard map. So we can see that. So this is the weighted average will be given. This is the peak ground acceleration map, and then this is the liquefaction motor amplification factor, and then predominant frequency BS30, engineering bedrock, and then geology map. All these things will be combined and taken into the one single map, giving the this is giving the low hazard and moderate hazard and a high hazard. So in all these activities, the geospace the GIS is well used in the generation of these hazard maps. So next to that, like this, we have completed the seismic zoning map at the microzonation map has been completed at say it is Jabalpur, Guwahati, Sikkim, Delhi, Kolkata, Bangalore, Ahmedabad, and Gandhidham. With the geological map scales 1:25,000 and 1:50,000 scale. Delhi has been completed with a much larger resolution of 1:10,000 scale on the geological map. In addition to this, we have already taken up the Bhubaneswar and 8 more cities: Bhubaneswar, Coimbatore, Chennai, Mangalore. These 4 cities is already in progress, and the remaining 8 cities: Agra, Amritsar, Dhanbad, Kanpur, Lucknow, Meerut, Pune, Patna, and Varanasi has been initiated. So next is the active fault mapping. So in active fault mapping, this is a GIS technique is widely used. This thing. So we know that an earthquake. What is this earthquake? Occurs when there is a displacement of 2 blocks of rocks along a weak zone, and that weak zone we called as a fault. And this fault maybe in the geographical time which has given rise to the earthquake, and it has the potential for the reactivation in future also. And that fault we call it as an active fault. Active fault mapping is one of the important input parameter for the seismic hazard assessment of the country. More than 60% of the country lies in high hazard zone due to the presence of major active faults in its plate boundaries and the continental interiors, which is produced large earthquakes in the past and have potential to generate major earthquakes in future. So besides interpreting, so how this active fault mapping is done? So we take the aerial and satellite photographs, and then and use the techniques like interferometric synthetic aperture radar, GPR, and GPS for the quantification of the active fault active fault mapping. So GPS and then GPS measurement will help us to estimate the slip rate and strain accumulation along the major faults in different parts of the country. So all this information will go into the GIS platform to create the national database of active fault mapping.
Could you sum up, Dr. G. Suresh, in the next 2-3 minutes, please?
Yes, sir. And another thing is we know that this is central seismic gap in the Himalayan zone, which has given rise to 2 great earthquakes, Kangra and Nepal, Bihar, as a potential for the and there was no earthquake in the past 200 years, and GPS studies have indicated that it is a potential zone for the future earthquake, and NCS is going for the earthquake early warning system also in near future. So what is the earthquake early warning? So here the principle is that because the P waves which is not damaging travels with 6 kilometers per second, and the damage causing waves, the surface waves and S waves, which travel with 3.5 kilometers per second. So when we keep these sensors close to the source region, and rapidly we can detect the P waves and then estimate the ground shaking, and then we can inform to the distant place like Delhi for the what is the impounding ground motion at the site. So the early warning system will contain the sensors densely spaced and close to the faults, and it is a completely automated system. Here, the robust telecommunication plays an important role because satellite communication has the lot of latency of 1 second to receive the data, 1.2 seconds about the. So we have to use the very terrestrial communication for the to decrease the latency, and then dissemination solve. This is everything automated process and quick and reliable notifications through automatic way. There are two types of earthquake early warning systems. So one is the on-site earthquake early warning, and the next is the regional earthquake early warning. So on-site warning wise is based upon the only one sensor, and it is the site conditions plays a major role for the giving the alarm. It may not be the accurate, and it does not take the directivity of the earthquake signal and attenuation loss, and it is just like a strong motion sensor which get triggers when this amplitude exceeds some level, and it is not reliable at all. So the regional earthquake early warning, which contains the number of sensors, densely spaced sensor near the source, and we get some lead time, and before the damaging wave comes, we'll come to know what is the damage pattern and what is the expected ground motion at a particular city. So this is the lead times we'll get through the with respect to the regional earthquake or early warning and the on-site earthquake early warning. So if the distance is about 100 kilometers from the source, we get the regional earthquake warning about 20 seconds, and then if the on-site warning is about 10 seconds. So regional earthquake early warning gives the more latency for the emergency operations. So this is the regional earthquake early warning system operating around the world, and this is a major. This is last year only, 2019 October. This USGS has started the Shake Alert for the public. They released it for the public, and earlier the first started by the Mexico and Japan, and Taiwan also has the earthquake early warning systems. So we have at present 115 seismological observatories. All these are broadband and strong motion sensors, and we are in near future we are going to upgrade. We are going to strengthen the observatory by adding 35 stations in the just in this financial year, and next in 2 to 3 years 300 new stations, and so we want to use both the weak motion data and strong motion data for the earthquake early warning system when the stations are located in the fault regions. So future plans: what is the network upgradation of the dissemination system, studies to delineate the subsurface structure over the Delhi region to examine the association of earthquake activity in a specific structure and earthquake early warning system. So thank you, sir.
Thank you, Dr. Suresh, and thank you for giving the details about the role of NCS, how it can help or it is helping to the nation in mitigating the earthquake-related hazard. So thank you very much. And before I go to next speaker, Professor Mukherjee, I will ask her to wait for 2-3 minutes because Professor Vinod Sharma, who has been at NIDM for quite some time, and then he moved at different continents, rather I will say, and came back to India again. So I'm very happy that he's in Sikkim nowadays, and he is with us today. So he would like to have share some thoughts of him with us, because he has to, I think, leave a bit early. So I think Professor Mahua Mukherjee will not mind if I invite Dr. Vinod Sharma ji. So Professor Vinod Sharma ji, please.
Thank you very much, Chairman. And I'm glad that you gave me this opportunity to talk to this August gathering. I would love to listen to Mahua ji, but I have a class and I delayed it already for 15 minutes. So in fact, I was enjoying the session, the first session, the second session, and even in this session, the presentation of Sushil ji, Anil Gupta ji, and the present one by Mr. Suresh. I think all the presentations are of great value, and particularly when the frequency of earthquake is very high since 1991. I can see that there was series of earthquakes, 91 Uttarkashi, 93, Latur, 95, there was Jabalpur, 99, Chamoli, 2001, it was in Gujarat, 2005 in Kashmir. And I think this country, these earthquakes, and it affected, life, people, but at the same time, we learned a lot. And Mr. Suresh very rightly said that the vulnerability today, it's more than 58% and in the country. And the recent map which he was showing, that now we have 4 seismic zones, and every time, we upgrade information. After Sikkim earthquake 2011, the entire Sikkim was seismic zone 4, but now it is changed. Some part, the seismologists are saying that it is in seismic zone 5 and rest is in 4. This is not important. Important thing is that the scientific knowledge is giving us many things, to get better prepared. And I am now in Sikkim as a vice chair, and after this earthquake, because in this earthquake in 2011, we had huge damage, urban infrastructure basically, even the central secretariat, schools, hospitals, rural villages, each and everything. But one thing was decided by the government, and I am grateful, to the bureaucracy and to the SSDMA that this decision was taken, that whatever we built in Sikkim after the earthquake, it should be earthquake resistant. And now there is a sort of government decision that whatever infrastructure we are developing, because we know that it is highly seismic area, whatever critical buildings, school or hospital, or you come to the Sikkim and see our central secretariat, it is completely earthquake resistant. So I think now the focus is on resilience. And I was so glad Rubab invited me, to the budget session, and we could listen to Honorable Finance Minister. She was mentioning about the Infrastructure Resilience Fund. So I think this is the intention of the government, and from the Prime Minister's 10-point program, from the agenda which we are having today, I think this is the intention that we should go for quality and not this L1, which was the normal, in government, we always see that who is the lowest bid. So I think instead of lowest bid, we should go for the quality construction and quality, particularly in seismic zone 5 or seismic zone 4. So I think the most important thing is that that hospital should stand in case there is any earthquake. And we have seen in Gujarat that more than 200 patients, doctors, nurses, they died because the district hospital collapsed. Same thing is schools, school building. So I appreciate, the Government of India decision, the National School Safety Program, which is launched by NDMA, and the entire country is benefited by that. The school safety program is not just the, seeing the school safety. This was one component that you see that whether the school is safe for the kids, for the teachers who are coming. But second part was to tell them, that how vulnerable, this area is, how vulnerable is a school, what they should do, what they should not do, do's and don'ts. And I think in some of the states, this was taken in a very serious way. I will give example of Sikkim, that in my state, in case you come, it is not only 2 schools in every district. We have taken entire schools, it may be government, it may be private. I think school safety program and the benefit should go to each and every one, because all the children are child of, the Sikkim state. So how we can differentiate that, how to select only 2 schools. So I think this way, the approach is changing. And we have seen that in the earthquake, we could see the loss to the heritage building, to the monasteries. And Sikkim is very famous, for the cultural heritage. And we have seen that enormous damage was there to our these cultural buildings. And now I think this approach of FICCI, particularly they want to involve private sector, into it. And they are partly successful, because now Government of India, they have allowed CSR, in investing in disaster risk reduction. So I think I compliment FICCI for their effort, because we are trying it, since long time, that the private sector can take a very active part, because they have now some money, to spend on this issue. So I think this webinar for 2 days, I think it was very useful. And I could see that in case you want to invite, Professor Murthy, Professor Ghosh, and Professor Anil Gupta and all that, it will take you one or 2 months, to decide how to bring them together. But thanks to the webinar system, that Rubab could do it, in 2 days. And he brought, the cream of this country, and people really who matter in earthquake engineering. And Mr. Chairman, thank you very much, that you are conducting this session so nicely. I will miss my colleague and my very good friend, Mohia. Mahua is, very well-known scientist, and she is doing wonderful work in Roorkee. I will really miss her presentation. I will have to go for a lecture, but thank you very much that you included me, in this session. And I'm grateful to FICCI once again, and to NDMA, that this kind of 2 days wonderful webinar organized. Thank you very much, sir. Over to you, Chairman, sir.
Thank you, Professor Sarmaji. Thank you very much for sharing your thoughts. It was really wonderful listening to you after a long time. And definitely all of us are getting benefited the kind of advice or kind of suggestions you people have, particularly the young people, though you said Professor Mukherjee, she's not that old. So I think all of us are getting really, benefited. So thank you very much, Dr. Sharma. And now I invite Professor Mahua Mukherjee to give her talk, please.
Yeah, I really thank you to give us this opportunity to listening to you people. And because with these only, at least if I have listened only maybe the second half of this webinar today, with that only I can confidently say that there is no dearth of knowledge. So I think my presentation at the end fits. Professor Sharma very rightly pointed out that how it is important to really go into the ground and to do the task religiously. That is very important. And I think in these, our planning can be a very good partner. So today I have identified the topic for you people, industrial ecology-based resilience planning. Without going for the initial introduction, making it lengthy, I would like to simply say industrial ecology, I have picked up this term to show that if every activity should have some principle. Here I have picked up that even the industrial safety, and which I believe it has to be for multi-hazard, not only for earthquake, there also probably industrial ecology can be the dharam. If we have this strategy with us, probably the resultant planning could be of a very different nature, because we are not only dealing the risk, we are also have the problem of the sustainability aspect, we have the problem of the climate aspect. So things together, I think industrial ecology can be a very strong principle which can help me a lot to go forward with my presentation. Resilience planning, already I told you that I would like to discuss this one, which is already being discussed and very nicely brought out by UN, that what is this resilience planning means. And it has been already discussed. Let me just give you, because we come from architecture planning, so we use lots of graphics. So let us just take this industrial estate, and there is a river here, there is some hills here, and this is the industrial estate, which is actually being properly fed by the supply line, which is here. So if we talk about the vulnerability, I imagine that there are certain vulnerable establishment here. Maybe here it is an old one chimney. Maybe this one is also, this is my just assumption. If so, already we know if there is a river like this, there is a chance of flooding, pluvial flooding. Also, there is a chance of, if earthquake happens, if the river is not getting sufficient areas and if the encroachment has happened, then those establishments, whether they are infrastructure or building, they are actually sitting on a very risky soil. So when we go for the exposure, we can easily label that area as high exposure. And maybe this one, I can just go for medium exposure. So if the hazard is flooding, then there are certain things which will have very high risk, because risk is defined as function of hazard, exposure, and vulnerability. And if our coping capacity is improving, then the risk is less. So it's inversely proportional. If there is earthquake, many things can go wrong. Maybe this lifeline can go wrong. Maybe this chimney can come out. So it is not only one single hazard scenario probably we are looking at when we talk about the resilience planning. Like very recently, we have seen this impact of earthquake hazards. These are very commonly seen, that we lost our industrial properties, we lost our this lifeline infrastructure. But recently we saw during the Corona period, when earthquake happened in Zagreb in Croatia, and we also saw that not only in our country, but when we saw that earthquake has actually, even in a country like Japan, could bring the cascading hazard. So multi-hazard scenario and the cascading hazard scenario, both the things can really happen, and we have to really keep that in our mind. I primarily chose the industrial estate for discussing this particular issue, which I would like to bring in front of this August company. Multi-hazard risk assessment, many a times, many ways are there to do the multi-hazard risk assessment. Here I am presenting one where we have tried to do it for the entire city of Dehradun, and there these indicators were actually being evolved, which is very much contextual to the Dehradun city. And it was done in 2015, so started in 2012. So the data, getting the data was a challenge, and we had gone for the GIS and some soft simulation softwares. Hazard and the vulnerability we picked up from the 5 aspects of vulnerability. Physical and social vulnerability really creates a very major role in case of Dehradun city. And each of these risks, urban flooding, fire, landslide, and frankly speaking, from the data only, we could understand earthquake is actually the 4th major important risk for Dehradun city. So accordingly, for each one, we have been able to do the risk index identification and also in totality, because for the city, for the authority, they have to get something in a comprehensive one. So we have also gone for the multi-hazard risk assessment, which was duly supported by this individual risk index and as well as our components from urban hazard. So then we could actually bring the multi-hazard risk map. At the end, I will show you how we have done it. I think today we have really listened too good techniques and tools. So I would not take your time to go into the details of it. But what I would like to bring in front of this company, that there is no dearth of knowledge, even the technical knowledge. But there is no implementation yet of these knowledge gathered comprehensively and compulsorily. That is the gap probably. That is also another, I will say, vulnerability. That has to be breached and our capacity has to increase. So we have gone for earthquake hazard for the Dehradun, and accordingly, we have followed a particular system. Primarily, Hazus has helped us for this one, and there are so many other models available, but we modified them as per our requirement. And then the urban vulnerability for the city was social, economic, infrastructure, and services. Housing was a very important vulnerability index we picked. Based on the survey and rapid visual survey, discussion with the community, discussion with the government, then only we could actually identify the indicators. Then the governance, that is so important. How this implementation is going to happen, that purely depends on the governance. So we also picked up that how this vulnerability can be assessed, because that was the total risk matrix for the earthquake. Here only the vulnerability part, and you can see that, as I told you, social, economic, physical vulnerability, and the urban infrastructure and the governance. And each index was also being weighted properly. We have used the AHP and other process, and this was the vulnerability index which was got prepared ultimately. And based on these exercises, after getting the vulnerability index mapping was created. For us, the architects and planners, mapping is the most important deliverable, because we believe that's a good way to communicate with the other stakeholders. So we had done this exercise in details, and ultimately this is the physical one, this is the social one. You could see that we have gone for the word level, because that is the administrative boundary we chose knowingly, so that if something can be identified for that word, we believe that the ward councillor can take it forward. So that way we always had an eye in the implementation. So from the vulnerability, from the risk, ultimately we could bring the social and the physical and the hazard one, three things together, and we could create the earthquake risk map. All these calculations, they are there in the this report. I'm not bringing all these things, but only to say that this mapping is so potential. It has gone through a very thorough process, which is important. This is only for earthquake. Like that, we have done the urban flooding, fire, and the landslide, which are relevant. And we could understand that when we discuss for the industrial estate, several changes are required. When I am talking for a city, it is a different context. When I am discussing industrial risk assessment, there are certain differences. What are the changes which I would like to highlight? Vulnerability indicators. Here we have gone for social, economic, environmental, physical built environment, and the governance. We didn't go for the infrastructure and the housing separately. Everything brought here, and environment is the another one which is very important for the industry. That has been brought as one of the indicators. Exposure and coping capacity. This is the particular. This UNDRR also supports this particular relation. More we actually invest into the mitigation and the preparedness period on the hazard understanding and understanding the vulnerability, assessing them properly, and bringing the risk matrix better, then accordingly our coping capacity and exposure can be reduced and coping capacity can be improved depending on how the governance takes care of all these initiatives. And we could see there is a sea change in the data collection and the interpretation. So the tools and techniques, there are so many different tools and techniques available within this 5 to 8 years. SCADA, BEAM, GIS was there. Now we are working with remote sensing a lot, drone, and now geointelligence, bringing this information together. That is very important. So now when we work in the layers, we get the data from remote sensing and we interpret it the way we need it. Here I am bringing one particular example, which is the talking about earthquake. Here we talked about how to really bring the urban risk. Again, the together, it's a urban risk, and I can discuss that in brief later. For the industry, economy is a big factor. And here, industry doesn't only mean the large sectors, it's also MSMEs, it's also the supply chain, it's also this people for whom we are doing it, the customers, consumers. The finance has to be properly done. So it is having many inputs, infrastructure, then this estates, their physical thing. And I have heard myself only that in the morning, there was a lot of good discussion on the infrastructure facility and the structure of the industrial estates. Technology and the policy part is not only the business continuity plan, that is only the very short-term thing, but also the disaster management plan for the these type of estates. These are important so that the loss can be less and less, and the industrial estate can really enjoy the resilience better. Likewise, the physical environment, there are a lot of things already. Just my previous speaker, before Professor Sharma, Dr. Suresh was discussing so many things. But the problem is, this information is available, but they need to be put in use. So that vulnerability atlas, seismic zoning map, microzonation, bylaws, code and practice, everything is there, but we need to really think about how to really make sure that industries, they really use it. Not only it's an eyewash, but they use it. Spatial planning, it can be individual estate, lot of discussion on the structure was there. But I believe when we discuss about this ecology-based industrial ecology, cluster can be a better skill to discuss with. Shared facilities, because we need to really think about not only the buildings, not only the structures, we also think about the infrastructure, equipment, piping. So there are many other things, and everything need to really come up much better than the previous one, building better. I don't believe in that term building back better. I believe in the very first goal, like Professor Sharma was telling, build better. That is the attitude, that is the principle we should have. Nature never wastes. Every time it keeps on improving. Don't wait for the next turn. So these are the type, regional to building level, we can really think about how to really make sure this vulnerability, we can assess it. And definitely the indicators we'll be using for this level. And when I come for one industrial estate only, the indicators should vary. And that's the most healthy way to assess the vulnerability. That is the only thing I would like to say here. And for this society, industrial society, the responsibility, social responsibility of industries are huge. It's not only within the industry, it is also beyond it. So symbiotic relation with other stakeholders, these everything what I have written here, everything falls in line in the industrial ecology principle. That is BCP to disaster management plan, long term. Nature always keeps on working for the long term. Geointelligence, try to bring the information together. Newer business opportunities, if something like Corona happens, what to do? Why these larger industries or even some MSMEs shall not be able to really go for some new business opportunity, so that not only they sustain, but other business estates also get the advantage of their knowledge. So this peer-to-peer learning is a great thing which can be harnessed better in this preparedness period I am talking about. Database supporting industry, lot of this data is coming into the feature now. So it is not only response and recovery I am discussing, definitely the shared facilities of medical, resilience, shelter, fire tender, rescue equipment, this should be there, but we need to also think about mitigation and preparedness, capacity building. Understanding why people are really looking for the environmental norms. So that awareness, that drilling, or multi-skilling, digital literacy, safety culture, many things can come under this mitigation and preparedness. And the last vulnerability point, which I have clubbed together, that is environmental and governance, because I feel governance really play a very havoc role here. So both the pollution emission, resource management, policy implementation. ARISE FICCI is one of the very strong partner into the UNDRR ARISE. So there are so many organizations who can come forward really to make sure that these policies are actually being implemented. Only having a good policy doesn't ensure our resilience. Resilient infrastructure, already this has been discussed. Challenge and opportunity mapping, not exactly from earthquake side, but this is from the other side, that's again the resilience, and it is from ecosystem-based approach only. Geospatial, where we have tried to talk about urban risk together, heat, flood, water crisis, air pollution, and the blue-green, the way the land use, land cover is changing. So we try to look at this, and there we have been able to bring some good do-it-yourself kit also, and everything is available in our website, center website, easily approachable. Anyone can go who are interested to look at how all these scientific exercises actually need to be translated in a much more simpler language. We have tried to do that so that it can be really implemented. People can really understand us. So this was the exercise which we have done with UN Spider Group, Dr. Shirish Ravan. They work with this remote sensing, and we really been able to get a very strong review from UNEP people for this exercise. And we believe that here for this urban risk, it is purely for urban area we have done it, but we have also checked it for the regions. There also it is equally efficient to talk about all those risks which I mentioned, but based on the data. And the data is not only the today's data, we also digged up the data of at least 25 years back, so that we also understand not only the problem, we also understand how to really implement, where to implement, where we can start thinking about intervention. So that's the way. It's a small example which I am bringing here in front of you people. We have done one small exercise, and I'm happy to share that DST has agreed to support this one under their water technology initiative. Gurugram Metropolitan Development Authority and IIT Roorkee, from center, we have the architecture, hydrology, and civil department. These three departments together, we have tried to think about how this Wazirabad Lake area can really be different, where we have tried to look at this ecosystem-based approach, and we tried to look at that if the rainfall is becoming a challenge, how we can really turn it into an opportunity. So we tried to also add some urban design aspects because it suits that particular context. So again, I am saying that resilience planning talks about this context a lot, and that is very important. And here again, I come back to my original story, where I try to talk about the Dehradun, and we talked about 4 different hazards, that is the urban flooding and urban fire and landslide and earthquake. And ultimately, after going through the entire exercise, we could identify which are the wards in the high risk zone, which are the wards in the next to that, and the 11 wards are in the medium risk zone, 17 are the low risk zone. And how it can help us? It depends on the lens. If it is a lens of an ULB, if it is a lens of an investor, if it is a lens of an industry person, depending on that, you can take a decision. Would you like to work in the response recovery or mitigation or preparedness or all 4 pillars together? So these things actually can help the ULBs to mainstream the resilience planning, because there they can easily understand that how this, we are really discussing this urbanization, the change of land use, land cover. We can have this quantitative idea through that NDVI, which I was showing you, NDVI, NDWI, that index can give us, we can quantify, we can interpret the data. So our master plans need not to be bland and very, very typical master plans. It should mainstream the resilience planning, because microzonations are available. We should take advantage of this advancement of the earthquake being monitored. So all this advancement can really come. It has to be dynamic. It cannot be a static master plan. No developed countries, cities are actually following this master plan concept anymore. They have their performance target. Accordingly, they are doing their planning. And why we are talking about resilience planning? Because resilience planning can take care of your sustainable development goals, SFDRR goals, and the climate change aspect. Regulation and code provision implementation, it can really help you know which one is actually weak in which word. So accordingly, you can take a decision. Okay, in this word, we need to really look for these things. And best management practices for relocation and non-encroachment. This encroachment itself need to be arrested, attenuated. You please don't allow anywhere and everywhere to have the urbanization. That doesn't really give the river a chance to have its own environmental flow. Later on, we come back and we actually blame the river. But river is not to be blamed. The encroachment is to be blamed. The surface transformation is need to be blamed. So stakeholders and ULB partnerships, stakeholders industry here, probably we are looking forward that they will come up with a very, very strong role, and ULBs. And according to all this risk assessment, multi-hazard risk assessment, you can also take prioritized planning. On-site, off-site planning, you discuss a lot in your business. Here also you can go for that prioritized one. Or maybe some government scheme is there. Based on that also, they can be looked into, where to intervene. And now the data, authentic data is available, and the process is much more easier than what we faced when we had started working in Dehradun 8 years back. So with this, I would like to really again advocate for this industrial ecology-based resilience planning. Hope you can take certain points.
Yeah. Thank you, Professor Mukherjee. It's really wonderful to give a different perspective of the total multi-hazard, risk management. It's really important, and this is entirely different topic, particularly in this session, because I didn't hear the earlier session, so I'm not really aware that whether something of this sort was discussed in the previous session also. But this is really very nice, and this is a rapid kind of hazard assessment which can be practiced, and combining with the hard data sets, whatever Dr. Suresh talked about. If all these things are combined together, probably we can achieve the goal in a much better way, and I think that is the requirement of the day. So this session concludes here. I must thank to all my five speakers, in fact, Dr. Sushil Gupta, Dr. Anil Gupta, Professor V.K. Sharma ji, and my colleague Dr. G. Suresh, and not last but very important, Professor Mahua Mukherjee. Dr. Sushil Gupta talked about a very important topic about development of, earthquake hazard model. In fact, that's a very good exercise, the RMSI has done under the leadership of Dr. Sushil Gupta. And definitely it can be, very useful to the people who are really working in this field, particularly engineering point of view. Then similarly, Dr. Anil Gupta also talked about the management perspective from government point of view, or rather administrative point of view, which is very important to combine together. Similarly, if we talk about Dr. Suresh Gupta, Suresh's presentation, it was giving some kind of quick information about the earthquake to help the all state disaster management authorities and central disaster management authority, as well as to go for the larger scale of hazard zonation. That's really fantastic. And of course, Dr. Mahua Mukherjee has put a different a viewpoint for this industrial ecology. That's really very important. So thanks to all of you. It has been really wonderful to listen to all of you, and I must, on my personal behalf, to thank CIDM, Vicky, for involving me in this e-conclave, which has been really very important topic for discussion. So thank you to all of you from my side, and I think the floor is for Mr. Sood now.
Before Mr. Sood comes, let me thank you, the chair, Dr. Bansal. Very nicely, you are actually bringing up the gist of each and every presentation, and you link them so well. Thank you.
Thank you.
Thank you so much, Dr. Bansal. Thank you for chairing this very important session, although it was the last session of this e-conclave, but I'm sure the sort of response we are getting from the audience, which is almost over 1,000 right now, we've got almost over 1,200 views already. I think the response is overwhelming. They're really pleased to listen to the presentations made by such eminent speakers. I think it has come, to a level where we are getting updates and comments from our participants that they missed out on certain sessions and how they can really make up for it, and that FICCI should do more of these deliberations, such interactions on this very subject. Because like during the inaugural yesterday, Mr. Kamal Kishore, Honorable Member NDMA, mentioned that a lot of discussions happen on relief and rehabilitation when you talk about earthquake. But from the mitigation and prevention point of view, there are discussions, but they do not, the other part of the discussion steal the limelight. And he was very happy that we at the industrial, industries level are getting the right minds and right people who can really talk about, the mitigation aspects and prevention aspects. And I think that is the key when you talk about earthquake resilience, which is the fundamental reason why we are meeting here today. That earthquake resilience, fostering resilience in industries and for future developments was the theme of this conference. So good we stuck to what we were supposed to do. And I'm sure with those eminent speakers and even more eminent chairs for our sessions, I think we could do justice to what we strived for, and where we, when we started yesterday. I think I must thank all of you present here and all the speakers who are not present right now on this call, but for all their contribution. I would, we have a couple of quick questions we'll take before we'll set on to the valedictory session. I'm pleased and very happy to welcome Mr. Raghu Babu Nukala, who was here just a while ago. I think he's the project director at GIZ, with the German Cooperation Group, very closely associated to FICCI CIDM board. I'm very also pleased to share with the audience and with the panelists that we have Mr. Rajeshwar Rao with us, who's just signed in, the senior advisor in the Economic Advisory Council to the Prime Minister. So we have his kind blessings and his support. He's member of the CIDM board as well. So when they say when you have the blessings from the right offices, I think you set out to greater heights. And I think I must take this opportunity to thank Mr. Rao, despite his very, very busy schedule, as we all can imagine. He's been able to come to us. Mr. Rao, we are taking 2 quick questions, and then we'll request you for your quick comments. You can meanwhile, I know you've just entered your office now, so you must be settling. So thank you so much.
Yes. Okay.
Thank you, sir. Thank you. So, quick questions. One of the questions is, what geophysical methods are currently used for short-term earthquake prediction? And that's an open question, Mr. Bansal, wherever you think it could be directed. Geophysical methods are currently used for what short-term earthquake prediction? Any such steps?
Actually, that's a very tough question. It appears to be very simple, but it's a very tough question. First of all, let me tell you, prediction, if you talk as such, prediction is not in existence. And what things are doing in this particular subject of science, we are trying to monitor some kind of different kind of rather precursory phenomena, whether it's a magnetic field, whether it's an electrical field, or whether it's a gravity field, whether it's radon, helium changes. So many are there, and sometimes we call force shocks also, but force shock is also not a very clear parameter, because it becomes force shock when you see the main shock. Otherwise, it remains earthquake. So things are really not that good looking. But of course, if you think from the seismological point of view, if you do the statistical analysis or nucleation pattern, particularly in Koyna region, what we have seen, some of colleague from NGRI, they have done some exercise on nucleation pattern. So based on that, they could give some kind of forecasting that a magnitude of event 4 earthquake can happen within, say, 15 to 20 days within a special window, because that's a very small area. So you can really concentrate on the specific kind of earthquake sources. But if you talk about Himalaya or other part of the country, it is just not possible.
Yeah, thank you. There was a question from Akshajit Poddar yesterday, and I'm bringing this up today because I'm sure this question is answered. That's why I waited. I did not take this question yesterday. Akshajit had asked how earthquake can be predicted using remote sensing and imaging techniques and by high space satellite techniques. I think most of it has been covered in the presentations today. So I did not, Akshajit, that is the reason I didn't take your question yesterday. So that's why I just brought it up. Next question is, so can we trust the density of earthquake events as an indicator for future events?
Actually, there are 2-3 things. If you talk about the quiescence and swarm activity, so at whatever past experience we have seen some quiescence and then sudden earthquake occurrence, and the main earthquake is there. But still, what you say, for example, I will give you the live example of Palghar in Maharashtra. So for last 2 years, we are seeing the seismicity, and we are sure that big earthquake is least expected there, because the earthquake sources are not good enough to store that kind of energy and release that in the form of big earthquake. So somehow what analysis probably we have done at the National Center for Seismology may be related to kind of hydroseismicity. Whenever this rain is there, too much of rain is there, some kind of relation. It is not fully explained, but some kind of relation is coming out. We will come out with more details on that. Similarly, swarm activity has been seen in many parts of the country earlier also, not in India, but outside also, let me tell you. But it doesn't mean that the density of earthquake is really explain the future earthquake occurrence in near future.
Right. Thank you so much, Dr. Bansal, for that comment. Last question, but I just wanted to, because this was an interesting one. How do trees and plants react to the pre-earthquake and post-earthquake signals and changes in the Earth's crust? Has there any study been done on this?
Actually, the main theory about this, earthquake prediction or forecasting or model or process, whatever you say, it's the elastic rebound theory. And elastic rebound theory is basically, the strain keep on building. If you see a field, for example, and you have some kind of trees, etc., there is an elastic, waves, elasticity goes, and whenever there is a change in the elasticity, finally it breaks at some point. So that is based on that basically. Sushil, you would like to add something? You are mute.
You're on mute. Sushilji, you're on mute.
If you see 1906, the San Francisco earthquake means the example came basically from there. So there was a tree rose, and because it had the surface faulting, so one side had moved to the other side. But these deformations are so small in geological time scale that it is very difficult to predict them from remote sensing or any other technology. Then you need a sensor which should be underground. And they are monitored for long period of time and at the known locations where really seismic activity is moving, strain is building up. So strain meters, if we can install and monitor them for a long time, then perhaps we can get some more knowledge on it.
All right. Thank you. Thank you, Sushilji. Thank you, Dr. Bansal. And I think there are questions which I would, we will take up from the chat window, and we'll email it to the speakers individually, so that, because I know there are certain questions which have been asked to specific speakers. We will do that coordination, and we'll make sure all questions are answered. I will take this opportunity to thank you, Dr. Bansal, the chair of this session, and all the eminent speakers, Dr. Mukherjee, Sushilji, Sureshji. You've been, we've had great Dr. Anil Gupta from NIDM. Great deliberation today. Thank you so much. We are really pleased. We are very thankful from FICCI, CIDM, all our partners, National Disaster Management Authority, National Institute of Disaster Management, EACPM, GIDM, ADPC, and our sponsors, principal sponsors, Swiss Re, associate sponsor, RMSI, Engineers India Limited for their technical support. We have Mr. SVR Subramaniam and Ms. Papia was also here. Yes, he's here. Papia Mandal Madam is also here. Thank you so much for all your support. So we would end this session now, ladies and gentlemen, and we would have a quick validatory session, because we have eminent dignitaries. We have Mr. Rajeshwar Rao. We have Dr. Muzaffar Ahmed with us. Dr. Ahmed, who's been listening to all the presentations, and I'm sure he must also be as pleased as all of us are. Dr. Ahmed, can you hear us, sir? I think his mic is on mute. I would request one of my colleagues, Varun, if you could please speak to Dr. Ahmed and request him to please come online. Yes, he's here.
Yes, Rubab.
Yes, Dr. Ahmed. Thank you so much, sir. Thank you. So, we had a successful fourth technical session today, the second of the day. We've wrapped up. We had some great inputs and insights from one of the best speakers in the country. I think globally renowned speakers were here with us for over the last 2 days. I think it's like a dream setting where when we were preparing this agenda, we had, you always start with writing names which perhaps you think they may not agree or they may not be available. But partly I would thank COVID, partly to the reputation what CIDM FICCI has developed over the past 15 years under the chairmanship of General Bhardwaj, Dr. Ahmed, Mr. L. Man Singh. I would take this opportunity to also thank late Shri S. Krishnan, who's former Secretary Government of India and former chairman of PNGRB, who's been, I'm sure he must be very happy for where he is up there, looking at us and being proud of what we are doing. Mr. Rao's, who's here with us, his guidance. I think we've been able to do justice with what we were set out to do. And thank you everybody for so much, for being a part. Thank you so much, Dr. Bansal, again, for all your support and sharing this session. I would take a moment, Dr. Ahmed, if you would like to please make a comment as we start the validity session. Your address, please, sir. Dr. Ahmed.
Thank you,
Sood,
Bob.
I need to leave. Actually, I
Yes.
have a meeting at 3 o'clock. Please don't mind. Huh?
No problem, sir. No problem. Thank you so much. Thank you.
Thank you very much.
Thank you so much.
Thank you,
We'll be in
Rubab.
touch. Yeah.
Am I audible?
Yes, sir. You are. Yes, sir.
Thank you, Rubab. I must tell you the 2 days technical sessions were really worth, because on the subject which is very important for the country. And I must compliment you, NIDM Professor Gupta, NDMA, Engineers India Limited, and other people who collaborated, coordinated with FICCI for organizing this 2 days webinar. And the experts of eminence, they had prepared very well, and their presentations were really excellent. I must thank them for sparing their valuable time, and I'm sure this type of technical webinars are going to be helpful to all the stakeholders in the coming months, and also in planning and how to prevent from the disasters, especially what was mentioned about the earthquake, of which what has been mentioned, more than 58% of the country is vulnerable to the earthquakes. And I'm sure the presentations which have been made by the experts of eminence will be taken seriously by our participants and those who have to take care of their industries, and those they have to take care of their units, or their, even if we talk about earthquake safety of our own domestic, of our own establishments, of our own residential places, because earthquake as such doesn't kill, it is the buildings which kill the people, and a lot of efforts are required to be taken to prevent from the deaths due to earthquake. And I'll say that FICCI's initiative in having these webinars has been appreciated by large number of people, and especially the collaboration which has been now with the NIDM, NDMA in a big way, and others, even the ministry, other ministries who are going to be on other important topics. And I'm sure large number of institutions, what we should involve now, the universities, other technical institutes in our future endeavors, so that maximum number of people get benefits from this. Organizing webinar is not an easy thing. Rubab, I must give you full credit, along with the Professor Gupta and your team, all Manik, Akhil, Varun, and all your Sanjeev, every one of you who work day and night for ensuring that these webinars become successful and people get maximum benefit. I thank all the speakers, and I thank you and Professor Gupta and our General Bharadwaj for taking the initiative, along with General Bindal, who has also been coming forward and always in our webinars. Thank you very much.
Thank you so much, Dr. Ahmed, for your very inspiring and motivational address. Sir. Thank you so much. It means a lot. I would now take this opportunity to welcome again and invite Mr. Rajeshwar Rao, Senior Advisor in the Economic Advisory Council to the Prime Minister, Government of India. Mr. Rao has been a member of CIDM board and great support. He's had a long career in the public sector, in the PSU, before he came into the central government, being a senior officer at the Petroleum and Natural Gas Regulatory Board before coming to his recent organization, which is now the EACPM. Over to you, Mr. Rao, for your comments, sir.
Thank you, Rubab. Good afternoon, everybody. In fact, I'm very happy to know from Dr. Muzaffar Ahmad and Mr. Rubab Sood that this e-conclave on very, very important topic of earthquake management for these last 2 days, yesterday and today, had 4 sessions covering very important themes. And also, I can see the success of this conclave from the time itself, because Rubab gave me the time of 1:15, 1:30, I was ready. Then 2 o'clock, I had a meeting. I joined around 1:20, 1:30, I think. Waited for some time. When I checked up with him, he told me then another 2 more presentations are still to be done. So that shows the success of this e-conclave. And I must compliment and I must agree with Dr. Muzafar Ahmad in complimenting each and everybody who is involved in this, in organizing this e-conclave, and also especially to Rubab and his team, Akil and everybody. I need not name, I think you are all aware of them. And this is an important topic, earthquake result, because several earthquakes in the recent past remind us that about the high level of seismic hazard and risk prevailing in the country. So if we go back to 2001, that was the first major earthquake happened in Bhuj, Kutch, in Gujarat, which actually sensitized everybody in the country about the earthquake disasters. So it is, as Dr. Ahmad said, that it is not the earthquake per se. It is the building and the infrastructure which causes the damages or the casualties. So we have to be very, very knowledgeable in preventing that casualties and the damage to the property because of these kind of earthquakes. A severe earthquake also causes economic stress in the short run, leading to huge economic losses. Means it will have an impact on the economy of the country also. So we need to be prepared for that. The need for a comprehensive methodology for evaluating the risk from failure of major industrial facilities due to earthquakes has recently been recognized. There are so many industrial units located in seismic zones. So they are to be, these industries specifically, they have to be educated in preparedness for mitigating the hazards due to earthquake. That is the purpose, I understand. That is why the CIDM board, FICCI and NIDM and NDMA have taken this initiative of organizing this e-conclave specifically for earthquake management. And also I'm told that it coincided with the earthquake day of that Jammu and Kashmir. That is really a great opportunity for this organizers to coincide with that occasion. And I must compliment them once again. And I hope this 2 days e-conclave has imparted a lot of knowledge. And as I heard for a few minutes before Mr. Bansal left this place, I heard from that question answers the kind of experts you have in this 2 days conclave. And also I must specially compliment the CIDM board, which is actually involved in this disaster management activities by imparting training and capacity building activities. And that is why, as Rubab said, I have been associated with this CIDM board activities for more than a decade now. It is almost more than 12, 13 years now. When I was in PNGRB, that is Petroleum and Natural Gas Regulatory Board, for almost 10 years. And after that, for the past 2.5 years, I am in the Economic Advisory Council to the Prime Minister. So we are associated, and ESAPM also is supporting the efforts of the CIDM board and the team led by Mr. Nirankar Saxena and Rubab Sood in FICCI because of the importance of the disaster management in the country. With these few words, I think I must thank Rubab and his team and all of you for listening to me and giving me this opportunity. Thank you very much.
Thank you so much, Mr. Rao. It's always a pleasure listening to you. It's always very inspiring, and you as I always tell you, you always bring the best out of us. And thank you so much for giving us those challenges every time we meet and we talk. Thank you so much. Thank you, sir. I would, I think every good thing has to come to an end, and I think we've had brilliant, very engaging 2 days of deliberations. If there is any final comment people on the panel would like to make to the participants, to each other, or to this entire concept, I would leave it open.
I would like to say, Mr. Sood, that thank you very much for organizing this event. At least we could meet, means our friends and colleagues, fellow speakers, means though virtually, but it was possible because FICCI organized this conference. Thank you very much.
Thank you so much.
For the
Thank
opportunity.
you. Yeah. Thank you. So thank you so much, Dr. Ghosh, Dr. Mukherjee. Thank you so much, both of you. It means a lot, as I said. Thank you so much. And special thanks to EIL and also to Swiss Re and RMSI, Sushilji. Thank you so much.
Thank you.
And Mr. Yogesh Bharat, thank you so much, Sureshji. My special thanks and special thanks to my, as Mr. Rao also mentioned, and so did Dr. Ahmed, multiple times during their address. It would not have been possible without the tireless effort and unwavering effort by the FICCI CIDM board, secretary of the team, Akhil Gupta, Mainak Majumdar, Sanjeev Kumar, Varun Sharma. Honestly, although virtual conferences looks like they're easy to manage and coordinate, but it takes a toll on you.
Yes.
No, we are getting used to it. We've been doing it for the past 6 months, but then every time it was a new challenge. Yesterday, we had a Cisco WebEx collapsed at 10:55. We was to start at 11, but we avoided the nervous breakdown. So a disaster had happened, but we could manage it well. And Akhil, who's our IT expert, he managed that, we should switch to Zoom. And so that backup worked, and we could do justice to the participants. Over 2,000 participants almost yesterday. I have the numbers now, views yesterday, and almost similar number today. So thank you so much, everybody. Thank you so much, ladies and gentlemen. Before we sign off, I'll have a small video from RMSI to be played, a 60-second video. On that note, thank you so much, ladies and gentlemen. Thank you so much. Thank you all the participants. Thank you. May this be just a beginning to many more such discussions and deliberations in future. Thank you so much. Bye-bye.
Thank you.
Have a great day ahead. Thank you. Bye-bye.
Thank you.
Thank you, sir. Thanks.